And it appears that we're live. Hello, everybody. Thank you for watching already. And this is my first hangout with Spurskimo. I asked if he could join today, and yeah, he's finally here. So, hello.
You all right? Hello. How's it going?
Yeah, okay. So, I told you that the thing I would like to do is today would be talking about your best argument of flat Earth. All right. So I would really like if you could present that.
In terms of what? What do you mean by that?
The argument you think is the most convincing?
Well, if you're talking about a model,
no, I'm talking about an observation that you think is proving flat Earth.
Oh, right. When we talk about things like curvature, spin. So to begin with, curvature on the horizon is what you might say is the strongest argument flat Earthers have.
All right, then expand, please, a little.
Well, according to the calculations, it's
according to which calculations? No, the calculation 8 inches per mile squared is wrong.
So why is that wrong? What's the mistake?
Do you have
This is how everybody understands it, and according to the model, the size, which is 24,000 kilometers all the way around, that would be the math.
Can you show me? If you can show me the calculation, I can show you why it's wrong.
Yeah, for example, we can see buildings 30 miles.
Can you show me? You say that when we are calculating the amount of building or whatever that is hidden behind the horizon, we use the formula 8 inches per mile squared. So what you have to do is to show me the actual calculation. How did you derive the result being 8 inches per mile squared from the geometrical properties of the spherical Earth model?
No, that's what we've been taught. It's not something that
No, we haven't. No, we haven't.
So what have we been taught then in terms of curvature when it comes to curvature? What have we been taught in schools about how to measure it?
You have to do the geometrical calculation. The 8 inches per mile squared is...
I know.
Wait,
what have people been taught in schools to determine the curvature of Earth? You're saying I've given you a calculation that I thought, which was...
Yeah, but you actually have to prove it first.
No, it's not about proving it. I'm telling you what we've been taught. You're saying that is wrong.
How's that relevant? You have to show me the calculation, and then we can find out together if it's right or if it's wrong. Do you understand that?
Not particularly, no, because we've been given. We've been given already.
It is not relevant what we've been given. We are developing this model now. We have a sphere with a diameter of about 12,000 kilometers. How do we derive the equation that 8 inches of any object per mile squared are being hidden behind the horizon? That is my question. Show me your maths.
Yeah, like I just said, if you know the size of any...
Please answer the question. Show me how you derived it.
You want me to go through the calculations of how you calculate?
You can do it yourself, yes, or you can simply show me where your source for the 8 inches per mile squared.
Yeah, well, this is the point. Instead of going through the nitty-bitty gritty.
No, this is not nitty-bitty gritty, because your mathematical equation is correct at small distances, but the error to the actual
that's what we're trying to find.
Is getting bigger by the farther the distance is.
Yes,
it's an approximation, but it's a bad approximation. That's my point.
Yeah, instead of having an argument, let's get to the point. So if I've given you an answer...
No, stop. You've made the claim that the formula is 8 inches per mile squared. You claim that we are teaching this, or by we, I mean people who think that the Earth is a sphere. Show me the source.
So where do we get this from then?
I don't know. Apparently not from schools, because they don't teach it.
All right, hold on a minute. I'll find you the source. If that's what you want, I'll find it. It's not a problem.
if I'm getting too emotional, just tell me.
Absolutely not. It's absolutely fine. We're here to find the truth. For me, it's not any type of competition. So,
What has the
are you allowed to
competition to do with it? I was asking you. You made the claim that
exactly
the formula is
not
8 inches per mile squared, and I just want to make sure that your claim is valid, and I doubt it is.
I've been indoctrinated. We've both been indoctrinated.
Actually,
So,
no, we haven't. So let's take the YouTube thing, and it's by
let's
death to
watch
the
this
globe.
video.
So let's take a look at. Give me a second.
Yeah, let's watch this video.
Yeah, let's watch the video. Does the video contain a actual mathematical derivation that starts with the spherical Earth model? Which
yeah, it does spherical trigonometry.
okay, give me the timestamp, please.
Well, that begins at 26 seconds or 25 seconds. Well, it starts at 20 seconds. Starts at 17 seconds, actually, so you understand how big the Earth is. This is how we work it out.
Second, I'll screen share.
It's your map.
Unfortunately, I can't send audio through from videos. I can't. I don't have the possibility to do it.
Screen share. See, because it's all about showing you why we understand what we do. And again, it's not a competition. It's not an argument. You're here trying to bash me on, well, what's your claim? What's your claim? It's not about that. We've both been
no. I'm not trying to bash you. What's your claim? I know what your claim is, and I want to know how you came to that conclusion. What sources you have to make sure that the 8 inches per mile squared is correct, and then we can take a look at those sources to make sure if the calculation 8 inches per mile squared is indeed correct, and I doubt it is. In fact, it isn't.
Look, this has got 250,000 views. If this is incorrect, I want to see your view of why. Why should I not believe?
All right, give me a second. I haven't seen this video before.
Of course you haven't, because you don't do the research, my friend.
Oh my fucking god!
And this is what this guy.
Stop.
This is all the proof.
Stop. Now they're claiming 8 inches per mile multiplied by the distance squared. So Excel formula. You mean the one on the bottom right over here? This one?
Yeah. If you watch the video, if you don't understand how it works, this will explain to you how we.
Give me a second. And so
if you can debunk this.
And in what way does it claim 8 inches per mile squared? There's no squared.
Yeah, you need to play the video.
There. Yeah, all right, okay.
There you go. Do you read?
Stop. Yeah, they're claiming that.
Right, so there's the claim. So that's why so many people believe this. Now, you can tell something different. I'm not going to argue with you, but until you can debunk this and show that we are testing your ball and you're not, this is why you don't understand.
What they just did, they showed a calculation, and then they came up with the 8 inches per mile squared, but it had no correlation to the equation that they were showing before.
No, it's going by according to the size of the ball. That's what they're doing it by.
You know that
at the beginning. If you look at the beginning,
okay, the beginning. Where? Give me a timestamp. Okay, we'll start from the beginning and let this run through once completely. Okay.
All right, go ahead.
And by the way, I think we have already debunked your 8 inches per mile squared stuff.
Well, whatever the calculations are, they don't comport with what NASA shows the size of.
Well, what the fuck has NASA to do with it? What does NASA have to do with a theoretical calculation that is only dependent on 2 factors, being the size of the object that you're standing on, or the size of the sphere, and the observer height over the surface of the sphere? Tell me, what has NASA to do with it?
Because they've given us the
no.
side.
What the heck? You're not understanding. You have to derive that formula. 8 inches divided by 8 inches. Do
you understand that the globe model has been changed over the last 500 years? So the size of the Earth has also been changed until today.
How so?
It hasn't always been. Well, you show me that it was 24,000 miles 500 years ago. You showed me that the sun was a million
Yeah,
miles
because
away.
their measurements weren't as precise as ours. That's to be expected. They had more primitive
Exactly. So I'm
equipment.
glad you just did that. So today we're precise. We know the size of the Earth. Therefore, we can test what those numbers are supposed to present.
Yes, I agree.
Yes.
So what?
So if it's a clay, if NASA or scientists, whoever you want to call, whoever get Wikipedia, whoever gives us those numbers, we either accept them or we test what we've been given.
The point I'm making is
Right.
the point I'm making is the formula that you're giving. You realize that stop. You realize that you can derive a formula of how far away the how high the drop behind the horizon is. You can derive that for any spherical object and for any observer height, right? What I'm saying is the formula that you're showing with the just the formula itself, not necessarily the 8 inches, but the per mile squared, the square part is the problem. It's geometrically incorrect.
Well, again, that's a claim. We're doing the tests. I haven't seen you do a diagram. I haven't seen you do a model. I haven't seen you go out in the field. I just hear your words.
Yeah.
These videos are doing the actual work that ball earthers are supposed to be doing.
All right. So then we will do the calculation ourselves, okay?
Well, you can if you want, but
yeah,
we can go for it. Absolutely.
We will do that in live. Okay, what I need is a. I don't want to do it with paint. I will use CorelDRAW.
Guys, I've been ahead of you, Alex. I've prepared a little bit of something for you.
You already have it.
Yep.
So
hold on, camera on.
Stop. Spur, do you want to go through this with Hector if he already has prepared it?
Yes.
Because
yes,
if I tell it to you, if Hector does, that's completely irrelevant. One of the two will do it anyway.
Hector, I'm not. If you can prove the ball without a shadow of a doubt, then there's no issue. I'm not here to prove.
It's not about the ball. It's about your claim that.
Currently, we're just trying to get our formulas figured out, because it seems like this formula is kind of at the basis of your argument. And if we're going to build on that formula, we want to make sure that this formula is correct.
Well, yeah. I mean, you just want to prove whatever's right. That's all. That's all I'm interested in.
We got it back there, nice.
Whatever's true. Right. If you have the correct formula, that's all I want to know. Not how mine is wrong. I've been taught by a different teacher. Now you're going to teach me that formula is wrong and what is the correct formula.
All right. I've currently got a camera feed open. Is that clearly visible? Should I zoom in more?
I think Hector, it's okay. At least for me.
All right. So.
Why don't you screen share him? Screen share.
Oh wait, give me a sec. That's my job. I forgot to activate it.
So okay.
That's okay.
All right. So. This here is basically the middle point, the center point of the Earth. All that is really not to scale. Here we've got the curvature of the Earth. This is the radius between the Earth, and basically this here is our observer. Now, we're looking at a straight line. So here's a right angle, 90 degrees, and basically we've got this long distance. Let's call that x. That's the radius of the Earth plus the height of our observer. That's the radius of the Earth. What we're interested in is this h, which is, let's just do the calculation in U, where h equals the distance x minus the radius of the Earth. X is the hypotenuse of a rectangular triangle, and we've got the angle alpha given here. So x equals 1 over cosine alpha times r. So our h resolves to 1 over cosine alpha times r minus r. Now, how do we find out our alpha? On the surface of the Earth, up here, we've got a certain distance that we're covering. That's d. The total circumference of the Earth is, let's call the circumference c, equals 2 pi times r. So the total angle here, the one total rotation would be 360 degrees. So if we're interested in a fraction of those total 360 degrees, we want to we have to take that into account. So in that case, alpha would be 360 degrees times the whole circumference of the Earth. No, basically our distance divided by the whole circumference of the Earth. That's the fraction of the circumference that we're covering, and with the, and by multiplying with the 360 degrees, we're turning it into the fraction of the whole rotation that we're getting, basically the angle alpha. So, putting that into our formula, we get the basically height of an object that we can see from the surface equals 1 over cosine 360 degrees d over c, and 1 over that. And I'll just pull the r to the outside of that, which means we've got the our height equals r times, open bracket, 1 over the cosine of 360 degrees times d over c, bracket closed, minus 1, bracket closed. Now, in regards to what you said about the approximation, it is possible to approximate the cosine function with an x-square function. However, that approximation is only valid for very low angles. And as we are talking about really small effects up here, this approximation is probably only valid for angles of 1 degree or maybe even less. And if we're talking about really accurate stuff, I wouldn't really use that approximation and go with the full cosine formula. So there's basically our whole formula. And with that, I'm going to leave my feet open in case you need it, and mute myself, because now I'm going to give the mic back to Alex.
Thank you, Hector. So you'll see this the geometrically correct formula. Where does your square law that you were talking about come in? As Hector explained, there is an approximation, but basically the bigger the distance, the less valid it will get.
This is a very good.
And also, in addition to that bigness of the distance, basically it's a similar version as to I'll just write it down here. You can approximate the sine of alpha, if you measure alpha in radians, as about alpha, and the cosine of alpha as about alpha square. Hold on. No. 1 minus alpha square. But basically what you're doing here is, if you subtract 1 from that, this 1 gets removed and you only have the alpha square remaining. And that means that a small error in the alpha square would usually just impose a small variation on our 1. However, as we're removing that by z minus 1 here, any small deviation on this has a much larger effect. So in that case, that approximation is, I'd call it completely invalid for any distance above 100 meters. And back to you, Alex. Sorry for interrupting.
All right. Yeah, no, it's okay. So Spurs, you've seen that we've given you the geometrically correct formula.
Absolutely. I couldn't disagree.
Then, right. Then, do you accept then that your one is false?
That could be false, yeah.
So that's
false. Look into it.
All right. Yeah, that's a fair answer. So I think in the beginning I interrupt. Stop. In the beginning I interrupt. Stop. Stop. In the beginning when you were, what the fuck? Okay, you go first. Fuck it.
No, I'm saying, am I going to be able to speak? Or are you just going to keep ranting at me?
I'm not ranting. I was asking you something, but we managed to talk over each other for some reason.
Because you just explained something. So how would it be normal or respectful for me to respond and reply?
Sure, go on.
So, Hector, you've given a mathematical equation here, which you would expect to see on a board. Yes?
Exactly. That's what you expect at a perfectly round ball. If you're doing it on land, you're going to have issues because, well, the land isn't really that flat in most cases. But yeah, that's what you expect on a sphere.
Yeah, absolutely. I couldn't agree more. So therefore, because you've made a claim, you've made an equation. Because remember, this equation has come from what you think it should be.
This
So the only
equation is
way,
based on the premise of a round Earth. Yes.
yeah, exactly, right. So the only way to test your claim would be to go out there and actually do the experiments, right?
Yeah,
Or would you
which about
or
50 people or so in the last year on YouTube alone have done and confirmed it.
Yeah, absolutely. So people should go out and test the claims that these equations, they make perfect sense. So let's go and test what you've just said. But we find that we see objects that you're not supposed to see
Source,
according to
please.
these equations.
Source, please. Can you name one example which is confirmed that it doesn't fit the expected value? Just one.
Well, if you're 6 foot, you're not supposed to see beyond 6 miles or 5 miles, 6 kilometers, something like this.
Give me a second. I'm going to calculate it.
That might be about in the ballpark, but even if those numbers aren't perfectly correct, just keep on explaining, and until something comes up where these exact numbers come up, I'm just going to interrupt you.
No, but that's what I'm trying to say. A car can measure how far it drives. It's like 1 mile, 2 mile, 3 miles. It knows where it is.
Yes.
Otherwise, that would be fraud. You can't mess with the speedometer or the dial. It has to be accurate, so you know how far you've driven. So if you're on a boat,
what's your point?
So if you measure how far you've traveled, and you know that an object is 6 miles away, and you can still see it, then this doesn't work with the equations that you've given.
Yeah, can you show one example?
Because in that case we'll have another effect come in, because you remember the drawing here. It assumes that the object that we've got is perfectly flat on the surface of the Earth. If, for example, an object is further away, let's say here, if it were only this tall, we wouldn't see it because it would be below my line of sight, which I'm just dotted here.
Yeah, I couldn't agree more.
And if, for example, if an object is that tall, you're going to see it.
No. According to your equations here, if the man is 6 foot and that object is the height of a normal car, I mean, even a boat you're not supposed to see. So a car's not 6 foot, is it? A car is lower than 6 foot. And if you can still see that object, then what does that tell you? It means that your equations are not wrong in the sense of it works if it was a ball, but it doesn't work in the sense of when we test what you're saying, it doesn't match up. That's the only problem.
So you're saying if my equation is correct, then but if my equation,
like your
based on the premises that I've made, is correct,
let's say, for example,
but it doesn't fit what I measure in reality, then it has to be the premise that's wrong. Correct?
No, I'm saying you've given equations for a board that somewhere exists what you have done, but not here. Yes?
No, because actually you have to demonstrate that the parameters you set in are correct, and that involves the height. Yeah. You have to know it exactly, and you have to know the distance exactly, and the height of the building or whatever you're filming. And whenever something is shown in, for example, YouTube videos that is claimed not to confirm the equations that we're using, it's either because somebody is fucking up the height of the observer, or the size of the building, or the distance, or more of the three factors simultaneously.
So I just
Yeah,
did the calculation, and as you said,
again,
6
guys,
miles corresponds to a horizon distance of about 3 miles.
you
So,
guys are
6
not going out there yourselves and doing the test that you're learning. You know, these students have got their heads in the books, studying for years and years, not actually doing the practical experiment to see if it comports with what you're learning.
How is it relevant if I do it myself?
No, it's very relevant because you won't know if what
No, it isn't. No, stop. Because you realize that we can write shit down, right?
Mm-hmm.
All right. And you realize that we can document experiments with the correct values, right?
Of course, everybody can document anything. Yes, you document your finding.
Yeah.
Of course.
No, but not only the finding, but also the starting parameters, right?
Basically,
Yeah, of course.
basically
You write it all down. Everything
document
is
because the thing is, if you're saying that I can't rely on experiments that were done that I didn't do myself regarding the curvature of the Earth, then I shouldn't be able to rely on any experiment that has ever been done because I didn't do it myself.
only ones that you believe and want to invest your time in.
Yeah,
So
for example, so I'm a chemist, right? I'm studying chemistry now in the 10th semester.
That's real science, by the way. Go on.
Yes, I know. Thank you. I didn't do most of the reactions that I'm performing or that I'm using myself as the first person. I'm relying on the lab reports of other people.
Yeah, but then listen. If you were to try to make some new medicine or pill, you would get the formula off somebody else. You would do it, and if it was supposed to be pink and it came out blue, you would say, "What's going on? Either I'm doing something wrong, or the paper is wrong."
Yes.
Okay, you're supposed to get the same result.
But you're forgetting that.
Results. Look, hold on. You get the same results as what you just said. So now you've just given me your paper. We go and test it, but we're not getting the same results. How can that be?
Yeah, the thing is that if I'm using a reaction that is documented in a peer-reviewed journal, then it's already been at least reproduced by another work group, not by the original authors, but by somebody else. For example, when you try to publish in the Journal of Organic Chemistry, and you propose a synthesis method, then another work group of another university is actually told to do the same experiments, the same syntheses that I did or that the publisher did, to confirm if my findings are right.
Exactly.
So now if a third person reads that, they can rely on the accuracy.
Yeah, but they still have to perform the test themselves. In fact, it's not just performing a test; they are copying you're looking at this differently.
No, we're not copying the results. We're copying the synthesis method.
But what I'm saying is, if you're making some type of medicine because you've seen the results of somebody else, that's all good and well. You know, there's no problem. Like I said, if you see something wrong, it's supposed to be one color and it's a different color, then you'll question it. So why would you? It's not a test. You're just following procedure now. Looking for curvature is not following a procedure.
Oh yes, it is. Yes, it is. Yes. Wait, stop. It is. You have to know your height. You have to know, well, regarding the thing being hidden behind the horizon thing. You have to know your height. You have to know. Wait, stop. You have to know your height. You have to know the distance, and you have to know the height of the building. That's the only procedure that you need.
Yeah, I agree with that.
Okay,
but I'm saying that's all you need. That's all you need. Exactly. So you've been given the formula. That's the formula is the height, the length, and that's all you need. So if we know the car is 4, 5, 6 miles away and it's still visible, then you have a problem with your equation here. That's all we're saying.
The problem in that case is that we're on land and not on water. And if I may just draw you another illustration of the problem, if this is your surface of a perfectly curved Earth, and we've got kind of a mountain ridge over here. If you're standing here, and 6 miles away from you, there's the car, then it might be that just the ground between the two of you is in a small ditch. And that ditch doesn't need to be very big. For 6 miles, if that ditch is just 3 feet deep, on the entirety of the 6 miles between the two of you, then it's not going to obstruct the view between the two of you.
Well, I understand, yes, but this was on the Salt Lake Flats, the flattest land on Earth. It's been measured. No dips.
Source, please.
Oh, right, of course. Let's do this. Absolutely.
But still, the problem is it flat in the way that it curves along with the Earth, so like this?
Yeah, you realize it has, Hector's right about it. It has actually to curve along with the rest of the planet. So if it's really flat, meaning two-dimensional, then
basically what I'm asking is
basically a ditch.
Is it this kind of flat, or is it this kind of flat, where it's perfectly flat here? Because if you're moving 6 miles on a perfectly flat thing that's not curved in any way, then your view isn't going to be obstructed. As I just said, on the entirety of the 6 miles, just an altitude change of 3 feet is going to ruin your experiment.
So you understand the difference between flat and level, right? That's the main problem.
Well, level.
Yeah, define level, please. So I just want to know if you understand what it is.
If the Great Salt Flats are just really flat in the sense of not curved along with the Earth,
yeah,
which would be this.
Not Hector. I'm talking about Spur. Stop, Hector. Don't spoil him. Yeah, Spur. Please define what level means.
We're going to go one better. You're going to screen share what the dictionary says. Yeah.
Sure. Level, being in a plane parallel or to the plane of the horizon, horizontal, equal as in one thing with another, or two or more things with one another, having no part higher than another, having a flat or even surface, even equivalable or uniform.
Did you just say having a flat or even surface?
Yeah, but let's go. Let's go on. Fill to a height. Here it is. Fill to a height even. No, that's not the wrong one. That's the wrong one. Fill to a height even with the rim of a container, mentally well balanced, sensible, rational.
Well, you've just said it. Flat. You've just said flat or even surface, and that's what everybody knows what level and flat means. Why are you trying to confuse people?
Because.
Hold on. You said there's a difference. Now explain the difference as you see it.
Level means, for example, when we're talking about the ocean. The ocean is level in the sense that every point of the surface of the ocean is in the same. Give me a second. I'm lacking the word in English. I don't know it. Let me think. Every point of the surface of the ocean is in the same gravitational potential. That's it.
And what do you take from that?
Do you understand what that means?
Do you understand what that means? What do you get from that?
The same gravitational potential would mean in that case that it's curving along the curvature of the Earth and not being kind of a
still showing Hector
flat area on the Earth.
Show me where the words curve come into that.
It's coming from the gravitational potential.
So when water's in a cup or over any object, we don't see this happen in reality.
Yeah, actually we do, and I don't think we can measure it on that distance, but over a few hundred meters or kilometers we can measure it.
Define gravity for me.
Gravity is a force that objects or particles with mass apply on each other. And it's always attractive.
And how do we measure it?
By measuring the forces that one body puts on the other one. So, for example,
in other words, you drop something and measure how fast it falls.
Yeah, for example, we can measure the distance to the moon directly, and we know.
No, what is gravity? What is gravity that you're talking about? This force pulling. What force is? How do you know? How have you tested this force pulling?
What has that to do with the ocean being level?
Because you said it's a gravitational.
All right, okay. how do we test?
You can't
How do
use
we test?
words
How
if
do
you
we
don't
test
have
gravity?
data.
How do
I
we
gave
test
you what
gravity?
level and
How?
flat is,
Stop.
and you said it wasn't.
Stop. How do we test gravity? Simple. When we have a acceleration-free environment.
Acceleration-free environment. What do you mean acceleration-free environment?
That there's no acceleration, no net acceleration. Weightless, being weightless. Do you know what that means?
So are we saying that there are objects in space, or what you call space, that are not being accelerated?
No, but we can, for example, in free fall situations.
So
Stop.
expanding. Is Earth expanding? I mean, not Earth, sorry, space. Is space expanding?
What has that? Don't change the
That
subject.
doesn't have anything to do with gravity.
Do not change the
don't
subject.
have acceleration.
Stop. Do not change the subject from gravity to the expansion of space. These are two separate subjects. All right. So what we can do, for example, there are free fall towers that are towers that are especially designed to make experiments in acceleration-free environments.
Mhm.
These are basically when you're doing your experiment, but the experiment is inside a capsule that is dropped from the tower. Have you seen that?
What, you mean the
Great.
ball and the feather?
No. Usually what you can do with it is, for example, test how small particles behave electrostatically in these environments. This is interesting if you want to know what happens when you have a bunch of space dust. Basically, don't interrupt me. How the first planetesimals formed, for example. You can test that with this.
Okay.
Great. Okay. The thing is, when you have a acceleration-free environment, that means that the attractive force, or let's just generalize it and say the accelerating force that the acceleration that you feel towards the ground is coupled out of the experiment, right?
The acceleration that you feel is because...
Yeah, you have this experiment. It's falling towards Earth, okay?
Okay.
That means in the system itself, in the capsule, there is no relative force between the objects regarding the falling down of the system.
No, look, if you're talking all this physics, which if nobody can explain what gravity is, how am I going to understand, or anybody going to understand what...
Hector, can you explain it better? Actually,
Are you ready to go?
Stop. Just give me a second. Spur.
Yeah, I'm listening.
Know that there's this universal law of gravitation.
It's not you. I'm saying I understand what you're saying, but I'm saying if scientists can't explain gravity and are leaving it to you guys to try and explain what it is, how...
Well, I can explain it to you, but are you ready to go on a really deep dive into quantum field theory?
I mean...
No, wait, stop. Let's start simple, okay? We have this universal law of gravitation. That means the gravitational force between one object to another is equal the gravitational constant times the mass of the small body times the mass of the big body divided by the distance squared, right? You understand that?
Right.
Okay, great. Now we can test this on different systems. For example, we can test it on the Earth-Moon system. We know the distance to the moon, and we know the time it takes the moon to travel around the Earth once. And that's, I think, all we need.
Look, this is the problem again. You're making these wild claims without any evidence. We haven't proved that this moon orbits anything.
Actually,
yes,
I've got an experiment. And Spurskimo, you're going to like that because I did that experiment myself. It's called the Cavendish experiment. Basically, let me turn on my camera.
Give me a second, I have to screen share you.
Yeah.
I think Spur, are you familiar with the Cavendish experiment?
I am familiar, and it's been debunked many times.
Oh, fuck.
No, it hasn't, because I did it. I did it myself in a lecture hall in front of all the other students of my
Oopsie,
of
sorry,
my
I
second
screenshot the wrong
semester
person.
lecture, and it did work. And we did measure the gravitational constant to about 5% accuracy.
Okay. Well, look, the title is discussing the shape of the Earth. You know, I wanted to just discuss reality, what we can observe. That's the only thing I
Yes,
want.
and we can observe gravity.
If I can see it, touch it, feel it, obviously, you know.
Yeah, and you can not only see it, touch it, feel it, you can also build
Some things will
machines
have to
that
go
are
by-
more accurate at detecting anything.
Some things will have to go on by faith, I accept.
No, actually, no, stop.
Does Australia
don't need,
exist?
no,
I don't
stop,
know. I've never been to
stop,
Australia.
stop. We don't need faith.
Well, yes, we do, because I've never been to Australia, and I only can go by faith that it exists, unless
No.
you've been.
No, we
Have you been
don't.
to Australia?
What?
Have you been to Australia?
No.
So how do you know it exists?
Actually, on a solipsistic point of view, I don't.
Right, so that's what I'm saying. It's on faith that you believe. You believe your friends. You believe what you've been told. That's all. I only want to deal with what we can observe, test, and repeat and verify. So we can all make these claims. Everybody can make these claims. I can make claims. You can make claims. You can write it down on paper. When you take your ideas, your claims onto paper, now you need to make those ideas from that paper come into existence. Unless it's in existence, it's just on paper. And that's all.
Okay.
That's where we're at now. You're showing me these things on paper. I accept them. I accept that what you're saying not proves where we live, but it proves the shape of a ball. But now, if you're going to say it's where we live, I'm going to test that. I'm going to test if I can see objects. You know, if I'm going to research if we can see things that you're not supposed to, and we can see them. So you have to explain.
Right. Let's go for one example. Can you pick one observation that you think doesn't match up with the spherical Earth? One example.
Well, like I've just
go
been
over that
saying.
in detail.
Yeah,
What?
Rowbotham's experiment says what he was trying to prove.
How do you spell it?
Was that Rowbotham, Robotham. Yeah, I'll even send you the link here, yes?
Oh. Just link it inside the chat.
Yeah, I will. So the point is, this is what we're saying. You guys make the claims. Fine. We're not even arguing with that, right?
Yeah, so you're not arguing with our claims.
Yeah, we're not arguing with the claims. What we're going to do, though, is we're going to test your claims, not accept your claims. We're going to test them. Once we test them, we're going to see if what you have told us is correct. It's as simple as that. And we found out that according to your model, that you're not supposed to see certain objects at a certain distance. That's it. So we've done it over land, we've done it over water, we've done the same experiment over land and over water, and the results are the same.
Yes.
The thing with executing the experiment over land, as I just said, is that it's really hard to test if the ground that you're on actually curves on with the Earth or is perfectly flat. And in that sense, it's not basically your experiment is unbelievably sensitive to small errors.
That's what I'm trying to say. You're saying it could be over the curvature. We're testing that if it is actually over any curvature, because if there is curvature, you're not supposed to see said object. We're testing as you're speaking. That's being tested. There was even a video now I've just sent here right now to Geo. We test it. Rowbotham's. He's done
it's in the chat. Okay, I didn't see it yet. So, yes. Can you make sure that the salt flat is level?
Well, I mean, look.
Yes or no?
You will have to. No.
Yes or no?
No, I can't. You'll have to test that for yourself. This is our claim. Now, either accept. Hold on. I'm not telling you to accept it. I'm telling you to test it. If you accept it, that's up to you. I've looked at the research and I accept that what you know, the geographical, what they say about the Salt Lake Flats, how it is. I accept that on faith. I haven't been there, but I accept it. Okay? If you don't accept it, you should test it. That's the whole point. You test a person's claims. So you don't just tell me to prove it. If you're going to make a claim, you have to test everybody's claim. If you're going to claim that ships go over the horizon, okay, I agree. From observer A, it looks like they're going over the horizon. But how do we test that person's claim? You need observer C. You need an independent witness to verify your claims, like in a court of law. Two or three witnesses.
You don't. No. In this
Well,
case,
if you really want to insist on having a person to witness it and having other witnesses, I can offer you about 100 people on a ferry in Greece. Is that okay?
Yeah, but
people
they're
that saw
all
the harbor disappear behind the horizon as the ferry drove further away.
Let me ask you this, Spur. Have you personally stopped?
Hold on, they are all observer A. And if you're observer A, you can't be part of the experiment. You need to move to a different position to become observer C. Do you understand? So it could be 1,000 people standing in a position, doesn't count.
All right, Spur.
Because I tell you why.
Wait, stop.
Hold on, let me just finish this.
I understand your point. I understand your point. It's okay. It's okay. I understand it. It's okay. I understand your point. But my question is, with your observer A and C analogy, what if you yourself are observer A and C? If you're filming something from two different locations, then you can verify it without the aid of further witnesses, right?
Yeah, if you can film it from two different locations, of course.
Yeah, and some people did, and they confirmed the curvature.
Well, that hasn't been published. Nobody's seen that. Nobody's tested that.
Yeah, I mean, if you're sending me YouTube videos as claims, then I might as well do that as well. Have you seen?
How about Brett's Blackwell Tower video?
The one that I was thinking about was Desert the Cameraman's ones with the volcano or something in New Zealand.
I mean,
yeah,
I don't
that would work as well.
As far as the Blackpool Tower, I think the 6 miles is what Rowbotham was trying to prove is sufficient. You don't have to go to any more length. He's giving you the measure. We've been given the numbers. So Rowbotham's experiment, until that can be debunked, you don't need to even look at Chicago's skyline. What for? We've been given the numbers.
The problem again with the measurement over the salt flats is, with the salt flats, we don't know for sure if they are actually curving around with the Earth or they are in themselves flat. If I may make an analogy, if you wanted to measure the curvature of the Earth by putting a very long wooden board on the floor that doesn't bend and measuring that whether that's curved, you're not measuring the curvature of the Earth. You're measuring the curvature of your wooden board. And in the case of the salt flats, what we're in essence measuring is not the curvature of the entire Earth, but the curvature of the salt flats. What's the reason why everyone is going to to water surfaces to measure the curvature is because the water is pulled into exactly the same shape of the Earth due to gravity.
Well, again,
and we want to measure whether the Earth curves, and with that the gravity curves, which means that the water is curving as well, instead of measuring just the curvature of one certain spot. You get my point?
Well, again, I would agree with everything if this happened in reality. You're talking about pulling and pushing. Gravity pulls, some water is pulling. None of this makes sense. This doesn't happen. Water
actually it does.
Water levels out, and is
always. Why does it do it?
Why does water level out?
Yes, because if there were no net force acting on it, it wouldn't do it.
No, water looks for.
Why? Why does it do it?
Alex, let him finish, please. Just let him finish talking.
Yeah, all right, okay.
Because it conforms to any shape. That's why.
Why?
What is it? What is the thing that makes the water conform to that shape? Is the question.
You realize that when the water changes.
It's the weight of the water. If you
Yeah,
drop
the weight. Thank you.
if you drop a bubble in a cup, it doesn't spread out. If gravity existed, then that bubble would spread out.
Surface tension.
Okay, so water conforms to the body.
Yeah, why? Because of the weight.
Of the water,
Right.
yes.
Yeah, because of the gravity of the Earth that is pulling on it. You
Basically,
realize that weight is basically the mass of the water times the acceleration of the gravity. That's what how weight is defined. Weight is a force. Yeah, it's a force. You realize the difference between weight and mass, right? Do you?
What I understand is that gravity is a theory. Scientists don't know what it is. They can't explain it. There is an equation for it.
Atoms are a theory.
gravity is a theory
Germs
that
are a
has been
theory.
tested and confirmed over and over and over again.
Do you know what a scientific theory is? A scientific theory is a construct that explains how different facts of reality are connected with each other.
Yeah, but they're not explaining it though, are they? That's the problem.
Yeah, they are.
I mean, I don't know how long you want to keep going on about the same subject. So I don't know. What do you want to? I mean, is that what it's all about? Just keep pounding on the same thing until is this?
Hold on. Regarding the shape of the water, I'm just going to give you a little example as to why it's gravity or the net force acting on the water that's making it basically shape it, take the shape that it has. Because there was also a small experiment that we did. Basically, if you've got a surface of water and you've got little water molecules in there, then you've got a lot of water molecules stacked up there, and these molecules have a certain mass. Objects with a certain mass are pulled towards the ground due to gravity. This means that water keeps being pulled down here due to gravity until, well, there's other water in the way and it can't move down. If for whatever reason we add more water onto it, let's say we empty a cup of water and for some reason the contents of the cup of water stack into the water like this. And there's further water molecules up here, and they are pushed down. These are pushing against each other, just like basically grains of sand would, with the difference that these have basically nearly no friction against each other. So they will spread out amongst the surface until the whole thing is turned into another flat surface.
Exactly.
Because the water molecules spread out across here, and basically they spread out across the surface, though that the surface of the water is perpendicular to the force acting on it.
Now show this happen. Do this experiment with a ball and make water conform around to the exterior.
That's interesting because we did an experiment where that was kind of the other way around. What we did in university for the Projektpraktikum is we took a bucket of water and we rotated the bucket so that there was a centrifugal force being applied to the water. So on the left side here, we had gravity that was pulling it down and a centrifugal force that was pulling it outward. So in total, we had a force this way. So the dotted line is the combined force of gravity and the centrifugal force. So at this point out here, we had a force shape like that, which meant that the surface of the water was
outside of the bucket there, not inside the bucket.
Yeah, I know. I'm giving you an explanation as to what exactly is working there. So this happened so that we had a 90-degree angle here. Now, let's go to the Earth. Basically, say this big piece of rock is our Earth. Here's its center of mass. Gravity always means that masses attract each other. So the field of gravity pulls down everything towards the center of that big rock that is our Earth underneath all the wet and green and squishy, meaty animal and human stuff on top of it. So the surface of the water everywhere here has to be at a 90-degree angle to that to the line in which gravity pulls it. So it forms a liquid layer around that big piece of rock. That's how it works.
You've studied hard,
Because-
haven't you, Hector?
It's less studying and more learning to explain stuff into this discussion.
I mean,
But
you
yeah,
really
kind of.
studied this stuff. You put a lot of effort into it, yeah?
I put less for that one. I put less effort into studying it and more about thinking how to properly explain it, because I think most of the time the issue isn't that people explain wrong facts, but they explain it in a way that makes them easily misunderstood.
Okay.
And yeah.
Go
So
on.
is it now clear how water works on around Earth?
Yeah, of course. What you're showing me again is great, but I want you to show me now in a practical experiment that you can do this.
What do you mean by do this?
Said that you swung a bucket and water was inside the bucket. I want you to do the same with water outside of the bucket.
Yeah, we would need a dense object, and we would be outside of the gravitational field of the Earth.
The problem is gravity is compared to the magnitudes of other sizes rather weak.
But we can create a vacuum.
It means that you need a really
a vacuum is irrelevant.
Yeah, but we
it
can
means
create a vacuum. Yes.
Yeah,
So
you don't need a vacuum for gravity. Gravity is only dependent on mass.
Hector, let him say it.
Okay.
Because you said you know what gravity is, you should be able to take that gravity into the vacuum chamber and
You can't take gravity anywhere.
Why
Do you
not?
know how the thing with any force
Why
in
not?
general is you have basically two objects which have to exert a force onto each other.
Don't you guys
And the
understand what
force
I'm
of
asking you?
those-
I agree with what you're telling me, but I want to see this now in observation. Now you've
The
given me.
problem with gravity is that it's dependent, that the strength
I'm
of
not
the
arguing. I'm
gravitational
agreeing.
field-
I'm saying great. This
Yeah.
is great. Now go
and
into
I'm
a
going
vacuum.
to
No,
I'm
yeah,
about to tell you what's
stop,
the problem with
Hector, stop. Spur, it's okay.
Yeah.
What do you want us to do with the vacuum?
So I'm agreeing. I'm saying, okay, now that you've given me the claim, I'm not arguing, but I want to see this in actual practicality. I want you to do an experiment that shows a huge body of the bodies floating around or orbiting around that other body. That's what I want to see. Otherwise, it's just a claim what you're talking about. Yes?
For example,
what exactly do you mean by bodies
I don't know
floating
how
around
you
other bodies?
Maybe I'm saying it wrong. I don't know how you would repeat this experiment that you're talking about. You're talking about gravity does this, does that. So I'm saying, show me how, in a practical experiment, this gravity doing what you're telling me, bending water, pulling objects. I want to see this.
All right.
I can show.
Stop, Hector, wait, stop. Remember when I was talking about the free fall towers?
Alex,
Yes, okay.
let's
Yeah,
go
okay.
with the.
Yeah,
Alex?
stop, Hector. If we had a tower that were high enough, and we were dropping two big masses inside of it, but it would have to be in a vacuum because of the air resistance, but it's possible.
Yeah, it has to be in a vacuum. I need to see this in a vacuum.
Yeah, but in this case, it's because the air around it, because we would have to have a free-falling system.
Look, again, I'm not even arguing with you. This might seem, difficult for you guys. Nobody's even disagreeing with what you're saying, but they just want to see it. They just want to see what you're talking about. Show us in an experiment that, this gravitational pull.
Yeah, for example, we can take a look at celestial bodies.
Alex, may I try?
Yeah, sure.
Have you the Cavendish experiment is still the setup for that still exists in one of our lecture halls. Basically, what it is, you have a long string of copper wire attached to a rod and two weights. Those are made from a non-magnetic object, so that there's nothing interfering with that. The copper wire is suspended from the top, and you leave it hanging for a while so that at some point this comes to rest, so it's not rotating. And let's say this is now a top-down view of it. So here's the copper wire. It's a rather thin copper wire. Here are the levers, and here are our
Hector,
two weights.
I think you have to move your camera.
Yeah. So, and here are our two weights.
We still can see it.
Oh, yeah.
That's better. Thank you.
All right. Now, we add in a second set of weights. These are would be here and here, in front of and behind the setup. So here and here, with the connection between them being below the point from where the cable is suspended. So this is a massive object, this is an object with mass, and these objects also have mass. So even if the force of gravity is incredibly strong, these two will attract each other. Now, you wait for a very long time until those have stopped moving. And oh, one thing I forgot to mention, on top here in the middle, attached to the cable, is a small mirror. That's going to be get important in a minute. Because now what you do is you take these, the lower two weights from the outside, and you turn them around so that this weight is here and this weight is here. Now, instead of being pulled this way and this way, the pendulum, the weights that are suspended by the copper wire are pulled the other way around. So they will start ever so slightly swinging this way. This is incredibly small and very hard to measure. It's extreme. You need to protect the whole setup, even from random airflow in the area. So the whole thing is covered under a glass, in a glass box. And now, because that's so small, this is the part where this mirror comes into play. Because you take a laser pointer and shine it onto that mirror, and you note the position where the laser, where the spot of the laser is reflected to before you turn the lower two weights around and after you turn them around. And you will actually see the point of the laser moving. I've seen that myself as the experiment was conducted in the lecture hall. And if we were to ever drop by at our university, I'm sure we could set up the experiment for you as well. And that's how the gravitational constant was measured. Basically the one constant in the formula for gravity. That's how you can prove gravity.
Well, you know, the Cavendish experiment is another pseudoscience piece of nonsense that has never been replicated and is taken as truth in the fraudulent world of scientism. So in essence,
scientism, stop. Hector just told you that he has done this experiment yourself. Your claim that it has never been replicated is factually wrong.
This was initiated in 1797 by Henry Cavendish, okay? A guy that supposedly can measure gravitational attraction of two massive bodies. This is a legend, okay?
A legend that I've managed to reproduce.
Replicated and is full of more holes than a piece of Swiss cheese.
Bullshit.
All right, name me one.
I'm
name me one
bullshit.
of those holes. Alex, shut up. And name me one of those holes, Spurskimo. Name me just one.
Okay, so look, you guys really need to research these things. I'm going to send a link.
I've researched it enough. Actually, I want you to tell me one of the holes in this experiment. You've told me that it's got more holes than a piece of Swiss cheese. I'm asking you for only one of them.
Yeah, like I said, these are things that you have to do the research. So there's so many holes in all
I did my
of
research. I already told you. I'm doing that. I'm basically aspiring to do that for my living. I did that research, believe me. I have yet to find one of those holes. So I would really love it if you were able to give me one of those holes. Because if there is a hole, I want to know it. If there is something wrong with it, I want to know it. So please tell me if there's something wrong with it.
Yeah.
And tell me what is wrong with it.
Yeah, you're going to have to speak to those scientists who...
I'm not speaking to those scientists, I'm speaking to you.
And to be honest, without any hard work, we won't find anybody who is more...
Here we go. There you go.
All right.
Another YouTube video. I'll mute my microphone for a second.
Can you summarize it?
No, just check it out and then
it's
come
only
back.
6 minutes. I'll just watch it and come back to you afterwards. I'm gonna mute myself and yeah.
All right.
Mm-hmm.
So Back to the original topic. Until
So
Hector
listen, what is your proof? Now you've asked me about my, what about you? What is your proof that we're on a spinning ball?
Spinning ball. Okay. Foucault pendulum. That proves the spinning. And for the ball, we have the drop of the horizon below eye level in rising altitudes.
You can also use the latitude dependence of the rotational frequency of the Foucault pendulum to prove that.
Yeah.
As it so happens, we're currently in the process of preparing a Foucault pendulum experiment. If you can give me an email address or something where I can send the report once it's done, I'm happy to send you another copy to you.
I mean, Spur, I've sent you my first of all, yeah, Hector's right, and second of all, I've sent you the plans for my stratosphere probe. Have you taken a look at them?
Yeah, I mean, I'll check them out. I mean, look.
Have you or have you not?
No, I haven't looked at it. Yeah, we'll look at it. But
Okay.
my point
Do you understand the math behind it? And do you understand the maths? And do you accept that results will be valid?
Look, we leave those things to you guys to work out those things. We only test what you tell us. That's it. We need to understand. We just need to know that what you tell us, we can test. If you're not going to do the observational, repeatable, verifiable tests, we will do them for you. So you just give us the results like you've been doing. Give us the claims like you've been doing. Do the maths on this bit of paper like you've been doing.
No, this is not a test on a piece of paper. We are actually building the two experiments right now.
No,
I have the parts of the
experiment.
stratosphere probe here, and Hector has told me has asked me to order the laser pointer that we need for the Foucault pendulum.
And I've been to the construction market the day before yesterday to get all the other things.
Both of these experiments have been debunked. Aries failure.
No. So
there's another one.
So
find,
can you show? Stop. You say that my experiment has been debunked, right? By my experiment, I'm talking about the stratosphere balloon. Just for the chat, I'll send you the link so you can take a look at it. Give me a second.
And another question: how do you debunk something before you know how it's going to turn out?
Yeah, but the point is, how can you know? Because you made the claim. We don't make the claim.
You made the claim that the Earth is flat, and to be honest, we've been here to ask you about proof of that.
Flat. We didn't make that claim. We tested your claims and said they're wrong. So we can only go by now our observations. Now we can only trust what we know, not what we think.
All right. You said Foucault's pendulum has been debunked, right?
Mm-hmm.
How was it debunked, and what about it is wrong?
And don't post another link. Explain it to us.
Because we won't have time to go through all the links that we could send each other. If we did that, we'd be here tomorrow evening.
People spend years and years studying, being indoctrinated, whereas people like myself will research your claims.
No, you said, stop. You said that you know that the Foucault pendulum is debunked. That means you have to have certain knowledge on why it is wrong and what is the problem with it.
Yes, because I've read articles, I've seen.
Yes, and try to explain it to us so we can look if you're maybe making a mistake or not.
Absolutely.
Go on.
Yeah, sure. So like I said, you're not dealing with any scientists here.
Yeah, I noticed that.
Yeah.
Unless you mean me doing observations myself, then we're all scientists.
Actually, what observation have you done? What experiment have you done yourself?
Well, I observe a flat horizon, a flat plane.
Which is what you would expect on a ball with a diameter of 12,000 kilometers on a height of 1 meter and 80 centimeters, approximately.
I've been in many planes, and the
Yeah,
horizon always
yeah.
at eye level.
No, it isn't.
Well, it's always at my eye level. I don't know about your eye level.
At 10,000 meters, you already have a difference between eye level and the horizons of 3.2 degrees. And this has been measured.
But to be honest, I don't think Spurskimo had a very precise angle measurement device with him. So I'm willing
Yeah,
to
but
concede that 3.2 degrees might not be
Hector,
visible to the naked eye if you're not specifically looking for it and having some equipment to measure it.
Hector, that is true, but a theodolite app in a smartphone will do.
Point taken.
And this has been done, Spurskimo. And if you don't...
Okay, so Falcon's pendulum, you have to push it. It doesn't start. If it was a real experiment and Earth was really rotating, you wouldn't have to start it in the first place. It would just
We already discussed
start.
that point with Anthony Riley at length. It was a few hours of discussion. In the end, he conceded that, all right, I get it, the centrifugal force thing does not work, and you actually have to start it yourself. If you want to do that to yourself, we can have that few hours of discussion here again. But for now, I would prefer if we could say, all right, this has been debunked, let's move on.
Look,
if you want to, the videos about the discussions are available in Alice's channel. Anthony Riley did get some fame, as far as I know. So
an object, you wouldn't need to touch the pendulum; it would just move on its own.
No, that's false. Because stop, and I can show you why. The centrifugal force, the Coriolis force, is only applies to moving objects. You can measure that. If the pendulum is not moving, meaning that if it's in the position of equilibrium, then there is no Coriolis force applied to it.
Coriolis is another myth. Stop using things that are myths.
You can measure it. You can see the effects of Coriolis forces on hurricanes. God damn it!
Stop, Alex. As it happens, I can also show you how the Coriolis force works.
Sure. Yeah, I could do as well with Hector's.
I mean, show in a mathematical sense.
All right.
For now, we're going to start with a standard three-dimensional coordinate system, with the x-coordinate being this way, the y-coordinate being that way, and the z-coordinate being pointing outside of the sphere, so towards the camera up here. Now, in physics, denoting coordinates is usually done with unit vectors. In this case, unit vectors are the vectors along the axis of our coordinate system. In this case, x, y, and z. However, this can be done with any arbitrary vector in any type of coordinate system, be it Cartesian, cylindrical, polar, or any other weird shit you want to come up with. In this case, the coordinate of our system, r of t, is explained as the sum over n equals 1 to 3 of the unit vector times ri. This is a number, this is the vector. This is basically the thing that connects the number here, which we use to describe our three-dimensional coordinate, to our vector.
Oh, yes.
Now, the velocity in three-dimensional coordinates is defined as the first derivative of our space after time. The acceleration in local space is defined as the first derivative of our velocity, which is equal to the second derivative of our location. I'm going to leave the of t out from now on because it's additional writing work and it's anyway not going to change. So now, Newton 1. Acceleration equals mass times force. Correct? Therefore, the force applied to our system equals 1 over the mass times the acceleration equals 1 over the mass times the second derivative of our location over time. All right. Rotating coordinate system. The rotation of a coordinate system is usually expressed by rotating the unit vectors. the rotation of a unit vectors is expressed using a similar using the same way as we express the velocity of an object via the first derivative. So the first derivative of our...
Stop. Spur, is there anything you don't understand until this point?
No, all understood. All understood. Continue, Hector.
All right. So now this might be a bit of a stretch. You remember cross products and how the vectorial cross product works in a three-dimensional space? The right-hand rule?
Right.
What?
Go ahead, Hector. Explain on this.
Okay.
One.
All right. So the change over time of our unit vectors. So let's stick with the n. Yeah, I used n as a floating variable. En equals the rotational axis of our system cross our unit vector. Now, the cross product of two objects is always perpendicular. This means that we're not stretching or squashing our unit vectors, which means that we're not having any issues with rescaling our systems. So this is valid for our coordinate system. Now, I did have my notes somewhere around here. Let me quickly check. All right. Now, what we need to calculate right now is what we now need to do is we need to calculate the second derivative of this here. This way we can get this, and if we divide that by the mass, we get the total force applied on our object as we see it from the viewpoint of our rotating system. Now, first derivative.
Hector, you still there?
Yeah, I'm still there. You just gotta think a little bit there. Equals. So let's pull the derivative in. For now on, I'm going to use the notation of del index t equals d over dt, which is going to abbreviate everything a little bit. Equals dt n.
Do you want to say something, Spurs?
Times ri.
Yeah, I'm listening. Pay attention.
All right.
Plus en of t times dt ri of t. Series function of the integral. So far, any questions about how that works?
You have to move your
Basically,
camera.
the step from here to here. Hold on. Oh yeah. So that's the applying an a derivative to multiplications. Is there any question of how I get from here to here?
It's got the product rule.
How did you get from there to there?
All right. New page for the explanations. So we keep the first page clean.
No, Hector, I think it's getting too complicated or too large. Spur, do you remember? Stop. Do you remember from mathematics? Yeah. But I think I can make this.
Him, Gio. He was doing something. Come on,
yeah,
let him do it.
All right. Okay. If you insist, okay.
Let him do it for the benefit of your video. Yeah, for the future.
So the derivative.
All right, if you want.
Okay, you've got two functions, f of t and g of t. Yeah, you can read that's in the image. And the derivative of f of t times g of t, that's called the product rule, equals the derivative of f of t times g of t, not the derivative of that, plus f of t times the derivative of g of t. That's usually, I think that's something you should have learned at school. If not, let's just say that we believe that this is something you got to believe me, because proving that is going to take a little more time than we probably have this evening.
And the mathematician probably.
But it's
I
good
can-
anyway. Then.
Yeah, it's basically is a series expansion of the Fourier transform, and yeah, it takes long. I could do that, but yeah. Now here we've got the left part. That's f of t, derivative of f on t times g of t.
Stop. Spur, do you want to say something?
No. I was going to say just carry on. Yeah, it's fine.
Yeah. So this is our f of t. This is our g of t. First, the derivative. First, we make the derivative of f of t times g of t, and then the other way around. Okay, that's the first derivative. That's basically our velocity. Now we need to do the same thing again. So we need to take the derivative of dt t r I t plus en t dt r I t. Now,
Hector, camera.
yeah, so we got to do the same thing again. And now this is going to get a little bit complicated, but I think we'll be able to do that and go through with it. Now, first, the left function equals dt of so that's the left part of which we're taking the derivative, plus then the derivative of the right part. Which equals, okay, dt squared en. This is dt times dt, which adds up to dt squared. You can do that with operators as long as they are linear and commutative, which is the case for the derivative times.
Camera, Hector.
Yeah.
Just push it up to the top.
Yeah.
Yeah.
It's kind of hard because the camera is halfway in my face, but never mind. Plus dt en of t dt ri of t. So basically, this extends to this part. So we still have the first function, which is g of t, and f of t and g of t. This is the derivative of f of t. This is the derivative of our g of t. Don't forget the brackets. And now we're doing the same for the right side, where we're getting t plus now all of this now comes down to basically we've got one term with the second derivative of our vectors plus the indices, 2 times the derivative, the first derivative of each of those, and 1 times the derivative of the indices and not the derivative of our vectors. Now, you remember from the top that the derivative of our vectors is this cross product of omega x en. This is going to get important now, because now we've got the first derivative of omega cross en ri of t plus 2 times omega cross en del t ri of t plus en dt ri of t and the del t squared. Now, the unit vector itself, en, is not en. in this case, is our radial. This is our basically rotation. As we're always rotating at the same speed, this is not dependent on time. As this is not dependent on time, so basically the derivative of something that's not dependent on the thing that after which we derive is 0, because this is the rate at which something changes as we change time, and this doesn't change with time. So this is 0. Well, hold on. Let me quickly check so I didn't make a mistake here.
Hector?
Ah, yeah, right. That's the calculation without the centrifugal force. And in this here, you remember the dt of RIT is our velocity. So we can put that in, which means that this is 2 omega cross En vi of t plus En times our acceleration of t. This is the Coriolis force, and this is the inertia term.
Hector, the camera again.
Okay. So this here is the Coriolis force.
Hector,
Yeah.
you finished?
Yes, I'm finished. So basically, what I was calculating here is the total force that's applied, and this is equal to the Coriolis force and the standard inertia in our system.
That makes absolutely sense on a globe model.
That makes sense in any rotation, any system that's rotating.
In any rotating frame, yeah. You didn't say anything about a globe.
I couldn't disagree anymore.
How?
It's a fantastic presentation.
Yeah, you've seen the mathematics. Where does a globe come into it?
I'm not sure. I might have made a mistake in the sense that I've omitted the centrifugal force. I might need to go through that again.
I think it looks good. It might be something you need to look at. But it looks okay. But I mean, it works on a globe model. Yes, on a model.
It works in any rotating system.
Even
if the Earth were flat but rotating, it would work.
Yeah, on any rotating system, this equation works wonders. Absolutely. Yes. But the problem is, we're not on a rotating board.
Well, that can be measured with the Foucault pendulum.
Foucault pendulum doesn't. That's not how you go about proving an object moving. You know, if something is speeding, like
yes, because what the Foucault pendulum is doing is proving that there is a Coriolis force, and that the Coriolis force is dependent on the latitude of the observer.
If you go to the moon and you see the Earth not spinning, how do you explain this Foucault pendulum?
If you again? Can you please? I didn't understand the first part.
Hypothetically, we went to the moon and we saw the Earth in its true form, and it wasn't moving, how would you explain all these experiments? You couldn't.
Fortunately, I do not need to explain it, because if you go to the moon, you fucking see the Earth moving.
Yeah, but I'm saying if I observe something different to your equations, what would you do? What can you do in this instance?
I'd ask you how you made your observation.
Because if hypothetically, if we went to the moon,
We did. We have video footage
Let's
from the
say-
moon. You
say
realize?
let's say we sent a rocket up, and we didn't see any spin. What would you say then?
Fortunately, I don't have to think about that question because
I know, that's the
because people
problem.
sent rockets up and saw the Earth rotating.
Show me this. Let's see. You've asked me to
Discover satellite will do. I
you asked
think.
me to provide videos and footage. I'm surely I can ask you to do the same. Now, provide evidence that we are on a rotating board. Otherwise, all of these equations make no sense. While you're doing that, because we've been talking a long time, just take a 5-minute break, quick cup of tea, boost the sugar levels, and then I'll still be here at the hang. I'm just going to be listening if you guys want to talk about what I've said, what Hector has said. Hector, great presentation, by the way.
Sure,
Yeah.
I would
But
suggest
still,
that if
I gotta go over it because I think I made a mistake that caused me to not take the centrifugal force into account.
Hector is what we would call a grade A student. Yes, he's someone who's dedicated to finding out how things.
Well, in my bachelor's certificate, I've got a B minus, so not really a grade A, but yeah, it's gonna do for a hangout.
I think I think you're being modest in this case, and I think you're the kind of person that would be welcoming to finding the truth, because that's what you want. You're not trying to deceive me. You're not trying to give me false images. You're trying to work it out, right?
Oh, just by derivation, do you think I want to deceive you?
No, I haven't said you're trying to deceive me. I'm saying that whenever I usually have confrontations with ball earthers, they're trying to deceive. You see, and they're trying to make us believe a fantasy. Yeah.
How so? I think
To be honest,
they're doing the same thing that we are doing.
But basically, I'm probably a little bit more calm and in detail about it.
Yeah, that's true, Hector. But because it's your subject, if we were talking about chemistry, I think we would immediately switch roles.
No, Hector's
Probably.
a lot different. He seems a guy who wants to actually know. He's studied here. You can see this. He's put a lot of work in.
That's not really a lot of work. It's kind of a first semester exercise in just math.
All right. I'm going to take that 5 minutes. I'm going to take a quick cup of tea. I'll still be here.
All right.
My question is. Do you
Alex,
want
let's
to
just take a 5-minute break.
No, because I will otherwise open the hangout. Do you want to have a closed hangout, or do you want the hangout to be open?
You can open it if you want, but I mean, be aware.
Right.
Be aware that it's going to turn into some type of
clusterfuck. I know that happens.
Terrain.
Yeah.
So that's fine.
I will open it.
Do it.
So we have here. I'm AFK for 1 minute. All right, guys, I'm back.
Okay.
So I'll now open the Hangout also for the chat. So Microblock, do you have anything to say?
Yeah, my main thing to have to say is that Spur doesn't get to fuck to shit on the work of actual scientists by calling them indoctrinated when he clearly hasn't done shit.
Yeah, that was really enraging also for me.
Yeah.
Guys, hello.
Ooh.
Hi.
I can hardly understand you. Your audio is really bad right now.
How about now?
There we
Much
go.
better, thank you.
Yeah, I had a Bluetooth mic or Bluetooth speaker going.
All right. Oh, am I still screen sharing?
Mm-hmm.
Yeah, I am. All right. Hello, Kara.
Hello.
I see we're going into one of Spur's 5-minute breaks. So
Well, there's a meth joke in here.
how many times are we going to switch topics? We went from flat and level to solipsism for a little bit. Now we're dealing with
to gravity, then back
pendulum.
to flat Earth, and then now we're at Coriolis force.
Yeah.
I don't know how that happens.
The pendulum only gets a start. Once it starts moving, it moves on its own. Oh, the one that's in Griffiths Observatory occasionally gets a magnetic boost, or a magnet will boost it a little bit, but the magnet is also part of the part of the pendulum that turns, so it's not an external force pushing on the pendulum.
Oh, that's clever.
Yeah, because people kind of think that the ball, when it's swinging at the bottom, is being pushed by magnets at the bottom. The one that's at Griffiths Observatory, every time it goes back, that's just a little electromagnet just giving it a little boost to keep it in motion. Otherwise, it'll eventually will go to the will lose its energy and stop.
It'll stop.
Yeah. But the actual magnet itself is actually part of the mechanism that turns, so it is not an external force. The pendulum. Kind of cool. I was going to go up there today, but I heard about this, so I'm hanging at home. I'll record the...
All right, I'm back. What did I miss?
Geo, you were talking about free fall. You know about the free fall vacuum chamber in Hamburg, right?
Yes, I know it. I've actually seen it.
Or Dortmund, I think.
Ooh, possible.
Yeah, it's the well, you know more. You'll probably find out more about it than I do. But yeah, there's a vacuum chamber up there, and it does drop tests.
I think Tom Scott did a video on it recently. Visiting it.
I'm not sure if it's in Hamburg. I think it's in Bremen.
It's the one in Germany. I can't remember exactly which one. I always get it screwed up too. I can't remember if it's Dortmund or Hamburg or Bremen.
Yeah, it's Bremen.
It's kind of fascinating, you know, how they had to extend the drop by actually accelerating it upwards and then letting it fall back downwards without having to make a larger tower.
Yeah,
so.
Hey,
yeah,
Steven.
that's basically double the time.
Hey, man.
Spurs, what's up?
Going on? Good to see you. How come you're not in Globebusters?
Oh man, not that I don't like them, but I kind of get tired of hearing the same thing over and over again.
Yeah, kind of. I know what you mean.
Told you I'd be here, Spurs.
Yeah, you were here after. You weren't here to disrupt. That's the main thing.
I'm here now, ain't I? I didn't say when I would come in. I said I would be here, didn't I?
Yes, but I was talking about...
there we go. As long as you understand English.
It's good to see you. Look, I know it looks like flat earthers have this huge, animosity against like wall earthers and all that kind of thing. I can understand that because it's...
Well, flat earth is a lie, so, I'm all about debunking lies.
You're messing with people's reality and senses and values. So that's why they're being
Spurs. What about my senses and my reality? How do we? If you're saying one thing and I'm saying another thing, how do we test? How do we use an independent variable to test to see if both of us are correct?
Exactly. That's what we're trying to establish.
No, Spurs. I just asked you a question. How do we do that?
No, it doesn't. Again, this is why you're in the problem.
Spurs, for example, you talk about gravity. And you say it's not how we that we don't know what it is. We can't measure. We don't do nothing. Just out of curiosity, do you have a cell phone?
Mm-hmm.
Okay, when you rotate your cell phone from portrait to landscape, how does the cell phone know which way is down?
It doesn't.
How does it know which way is down?
How does it know? How will it know?
It's got a gravity sensor mounted.
Hey, no, shh. He's asking him.
Oh, okay.
Yeah,
Spurs, I'm asking you. How do you know? You said Spurs. You made a claim. Spurs. Let me answer you. You made a claim that we do not know, that we cannot test this, that scientists do not know the answer to this. We know this every day. Not only that we know it, we build the equipment that use it in practical applications. So once again, when you rotate your cell phone from portrait to landscape, how does the cell phone know which way is down to keep the screen orientated?
Who knows, man? Prove your claim.
I mean, who knows? They actually built it. You say who knows, but that implies that when they built this device, they didn't know what they were doing.
Of course, they knew what they were doing.
So people do know.
Yeah, that's what I said. I asked the question. Who knows?
No. Okay, guys, don't fall into this trap. I know you're onto it, but don't fall into this trap. So there's only two correct answers here, Spurs. It's either I don't know, or you explain how you think it works.
I just said I don't know.
Okay, so you have a cell phone. It goes from portrait to landscape.
Yep.
Yes. And when you rotate your phone, how does it know to do that?
No, how does it know which way is down?
Maybe it has a bubble in there that keeps rising up, and when you rotate,
are you sure?
It just stays up. I'm not taking.
Are you sure?
No, guys.
But that's one way you could do
it. Are you sure?
Yeah, guys. Okay, don't confuse this, guys. He's not saying that's de facto how they do it. Okay.
Conversation.
He's giving this as an example for how you.
Okay, I understand.
Which is correct. You could do it that way, right? The only problem is that would require a relatively huge amount of the physical space available in a phone.
Yeah, yes, it would. But
also,
it's not something that's feasible. That's my point, right? So that answer, while it would work, it's not feasible on modern day devices.
Well, besides the fact that the size, but if I took the phone and shook it from side to side, would make the screen shift from left to right because the bubble moves.
Also, you would there's a chance of the bubble breaking up, which would screw it up even more.
Or the liquid getting cold and stuff like that. So once again,
let me just turn on my camera and draw the image on how those acceleration sensors work.
Oh, come on! Oh, God!
No, don't answer for Spurs though. You're doing it now.
Yeah.
Okay.
Yeah. So again, the correct answer from Spurs would be, I don't know, or give an explanation how he thinks it would work, or give an explanation of how it actually works if he actually knows how it happens. And that's what Geist is trying to figure out. Does he A, know it, or does he B, not know it?
I don't know. I don't know any. All of these claims that you're making, I don't know any of them.
It's not a claim, Spurs.
It's not a claim. He's asking if you know. And you saying I don't know is a perfectly valid answer. Now, guys, you can go ahead. I'm sorry for being like a quasi moderator.
You're fine.
This is what Spurs does.
I asked him, who knows? I asked who knows.
You're talking about who knows, like in nobody knows how this. Are you trying to? Okay? I want clarification. Are you asking like? Are you saying?
Who knows?
Are you saying who knows as in? Are you saying as in who knows, like as in nobody knows, or like in who knows, like do I know?
Well, that's the question.
Which one is it?
The question is, well, try to listen to me then. The question is, who knows?
And I'm trying to get clarification, as in who knows, like as in nobody knows, or who knows, like somebody, or somebody can answer the question.
He's answering a question with a question.
Yeah,
and it's a stupid thing to do, Spurs. Answer the question. Do you know, or do you not know?
He's essentially afraid of saying I don't know, even though we just did it. He has essentially answered that I don't know.
Thank you.
Okay, the thing is, Spurs likes to play
Don't
word games,
answer
so I'll
with
just
a
make sure
question.
he's...
How many times do you want me to keep saying I don't know? I don't understand.
Okay,
Pay attention,
Spurs.
Tara. This is your problem.
Spurs. How a cell phone knows which way is down is due to a device inside the phone called an accelerometer.
Who knows? I don't know.
There we go. Now, see, people
no,
talking about...
Like ice cube knows.
Now this was a statement, not a question. In case you're confusing it.
Yeah, I know.
Guys,
Spurs, that little device in your phone that tells you which way is down, and it's not your digital compass, it's which tells you which way your phone tells your phone which way is down, no matter which way you orientate, unless you have the thing on fucking rotation lock, is called an accelerometer. The accelerometer is measuring the force of gravity, and how it does that is the acceleration 9.8 meters squared.
meters per second squared.
Yeah, I'm not going to go into that kind of fine detail with him.
Essentially, it's a tiny conductive silica element that measures differences in accelerations in different vectors depending on the resistances in it. So it measures the difference in how current flows through it.
And how you can test this is, Spurs, is take your cell phone and accelerate it upwards at 9.8 meters per second, and I guarantee your cell phone will not know which way is down because how the sensor works. So we do know what gravity is, and now do we know it? We build equipment based on the fact that we know what gravity is.
Oh,
gravity is not a guess.
Well, instead of measuring gravity, we could be measuring biometric pressure.
Nope.
No.
So again, just for clarity's sake, and I'm sure Hector can do this as well or confirm it. These units are actually physically sealed. They don't actually measure any difference in pressure. Pressure, something that measures pressure is first of all, it's not available in all phones, but in the phones that it is available, it's a completely different circuit.
Yes, pressure, and also you can't use pressure measurement on the scale of a phone to detect the orientation of the phone, because if you were to place a pressure sensor on both ends on the phone, they both measure about the same pressure. And if you wanted to measure the orientation of your phone via pressure sensors, you'd need to measure a difference between those two, and you're not going to notice that difference.
You could confuse it by blowing gradients.
Yeah, exactly. I was about to say that.
Confuse your phone.
Yeah.
So the first problem with this right here, we're going off on a whole separate tangent, is an accelerometer doesn't measure pressure. It's not designed to, doesn't do anything about pressure whatsoever. So that thing goes right out the window.
Yeah,
you can take an accelerometer and freeze it in a block. You can freeze it in a block of ice. You can heat it up. You can wrap it in a fucking lead that's 30 feet fucking thick. It still will work.
Yes, because it's physically sealed from the environment. It has to be, or else it would actually corrode away and stop functioning.
That's actually the case with basically a lot of the fine mechanical circuitry that we've got in mobile phones. If you're interested in it, I can draw you a sketch on how exactly those accelerometers work, because that's a real interesting application of solid-state physics.
Yeah,
but the reason why I brought
fascinated how they actually made too.
The reason why I brought this whole thing up is when Spurs says we don't know about gravity, it's just a theory. If it's just a theory and as in just a guess, then we build pretty sophisticated equipment that works on such a guess, and you use one every day, Spurs, on your cell phone. So every time you turn that thing, you're confirming gravity.
Also, fun fact: your sense of balance works by the same principle. In your you essentially have a sort of accelerometer in your inner ear. That's how your body knows where your head is.
And your inner ear doesn't have a little bubble.
Nope.
Anyway, Spurs, if you ever come to take a holiday in Germany, you are hereby invited to join me at the University of Erlangen, so we can repeat the pendulum experiment to measure gravity.
I'm actually tempted to drive to Germany just to do that.
Just in case he's ever going to take a holiday here. I mean, there's a lot of castles.
And Spurs, you're actually also invited to watch the stratosphere experiment.
In case you ever come here.
May I ask, so I approximately whereabouts you would be? Because it's actually kind of likely I'd be there.
Any of your experiments.
Stop.
This is
stratosphere alone?
This is not how you guys. This is not how one would go about proving anything. If you want to
by experiments? Sorry, Spurs.
Yeah,
sorry, Spurs. Our thing of experiments is not watching YouTube videos.
Yeah, watching YouTube videos of people doing the experiments.
Spurs, but then you will say, but you will tell us, Spurs, hold on, but you will tell us that we need to conduct experiments for ourselves, but you can only watch fucking YouTube videos. You're a fucking hypocrite.
And then post your results.
Spurs, online. You are a hypocrite.
We are going to do that, Spurs. As I said, just give me an email address and I'll send you the copy of my report.
So Spurs, after he sends you the results, are you going to go conduct this result? Are you going to go conduct the test? Or are you going to go watch a YouTube video?
I'm not disagreeing with any of your findings, your work, but they have to be tested. Yes.
Spurs, and how are you going to test them? Spurs, you going to watch a YouTube video?
Well, no. If he gives me something to test, I'll test. Absolutely.
Repeat his experiment.
You have to repeat the experiment, Spurs. You can't go do something on your own. You have to repeat the experiment and find a flaw.
Well, no, if he says this...
no, Spurs, that's how science works. He makes a claim, he says, this is supposed to do this, and he gives you the specifications, and then you go build such device, and then you find out it's not working, then there's a problem. It's not, he builds a device, and then you go build something completely different and go, well, wait a minute, mine's not working like his is. And then
of course, if I build what he gives me, of course it will give the same results. But
no, it won't. If there's something wrong with it, then it won't work.
And if there's nothing wrong with it, then it's gonna get the same result. I think that
he's building device A. You're trying to build device C and then say A doesn't work.
Whatever contraption you've built, every time.
No, Spurs. That's how we test.
Spurs. But when I used the example of chemistry before, when I read an article and a synthesis looks fishy, I am going to test it. By doing the same thing, by doing the same synthesis, even on the same scale, 1-to-1. And yeah, there are always small differences because of mechanical workup and so on. But if there's something wrong in general with it, you can see that after your experiment directly.
Well, like I said, that's yet to be tested, what your claims are, what you're saying.
Yes, but Spurs, once again, somebody is building device A, and they want device A to be tested, but you're going to build device C, and then wonder why fucking C isn't conforming with A.
Every test needs to be replicated in the
Spurs,
university.
Then Spurs, and what tests have you done that debunks Foucault's pendulum?
And they also need to be
guys, may I propose a small solution here?
Yeah.
Let us do our experiments. Write reports on those experiments, publish them to all of you, Spurs, Anthony Riley, anyone who wants to see them. And then if someone wants to repeat them, he can take a look at our transcripts, how we did things, the things we took into account, what we did to get rid of inaccuracy.
Never tested that Earth until now. Now you're going out and actually doing it.
Bullshit, Spurs. We've been testing the sphere Earth for hundreds of years.
Actually,
thousands of years.
Spurs, you live in the poison well fallacy. You know that, right?
Years.
So much for proposing a solution.
Yeah.
Let's just say we're going to do our experiments. We're going to do a detailed report of it, what we did, how exactly we did it, the things we took into account, the accuracy and inaccuracy of our experiments. That's also very important in science. One thing that our lab course tutor once told us, any measurement without its accuracy is worthless. So we need to know how accurate the measurements is. We're going to do calculations on the accuracy of our measurements, and we're going to publish all of that. And if anyone wants to repeat our experiments to the same standards that we've put on, with the same standards that we've imposed on ourselves, the same standards that we wanted to adhere to, then we're going to look at their experiments and see if there might be something wrong with that. Because, to be honest, there's a metric fuck ton of shit that can go wrong in science. For example, in one of our lab courses where we had to design our experiments ourselves, we wanted to measure whether a charged sphere of metal when we rotate it, has a homogeneous magnetic field on the inside. And after doing a lot of experimenting around and measuring just absolutely nothing, we ran our numbers as to either how fast we would need to rotate it or with how much voltage we'd have to charge it to get a good result. So, and we basically said, in order to get something of a magnitude that we can measure, we either have to rotate it so fast that it's going to instantly shatter and make a 2-ton airdrop bomb from World War II look like a plaything, or we'd have to charge it with a voltage that would probably instantly annihilate the entire building due to the big as lightning we'd produce. So that's also an example of finding out that that trying to conduct that experiment was bullshit. And just as an example of, there are a lot of things that can go wrong in science. So you do your experiment, see what comes out of it, and if the results seem odd, ask other people for their opinion on it and as to what might have gone wrong, and see if you can fix it. That's how science works. And let's let that science work before getting into a fight about what you suspect Spur might do to discourage it before even knowing what he did. Before reviewing his work, let him do his work.
So, Helso, you wanted to know where we are conducting the stratosphere experiment?
Yeah, it's like approximately. I don't need an actual address.
About 35 kilometers southeast of Berlin.
Oh, okay.
The problem is, me and Hector, we are living in Bavaria, but for some bureaucratical reason, the maximum mass for balloons you can launch here in Bavaria is 800 grams. And the balloon itself is heavier than that, so we have to go to another state to do it.
Ah.
Yeah, that's shitty.
That's German law for you.
Yeah. Hey, have you tried like Rhineland-Pfalz?
I think I've written an email to the guy who from the Rhineland-Pfalzian authority, and there was some problem with it. If you guys, if you take a look at our stratosphere balloon itself, we have those big levers with the scales attached to it, and most states didn't like that concept. They thought it was too dangerous.
Oh, too bad you're not here in the States. You can launch all kinds of shit up around here.
Yeah.
And then shoot it down.
Well,
that's America for you.
The population density in the United States is fairly low, though.
Yeah,
that's true.
Yeah, the problem is, it's
I
more
mean,
or
in
less
Germany,
approved.
you've got like 82 million people on something the size of
half of Texas.
Like a couple of states. It's yeah.
And the thing is, unfortunately, the only location that we can use, because we actually need the approval of the owner of the location and the mayor of the town in which it's in, and so on and so forth. So the only location that we got is the one village southeast of Berlin. Unfortunately, we have to make sure that the probe doesn't enter Poland airspace. So we have to wait for a day when the wind is blowing from the east, which is kind of rare here.
Oh no, the Germans are attacking again.
Yeah. Yeah, with running accents and cameras. I think we would figure out more effective ways.
Yeah.
So a question for Spur.
Yeah.
See what's on my screen?
Oh, wait, I can share it.
Yeah.
Ooh, that looks fancy.
Oh yeah, that's kind of exactly what we did in our lecture hall with the Cavendish pendulum.
So what do you think is wrong with this experiment? Like, where are we misunderstanding the input? Basically, we move these masses nearer to this torsion bar, essentially. And as the masses get closer, it deflects the light more and more. So there's a force between these two objects. So what else could we call this?
Like you can do it at home with home
So the results.
Now keep in mind that the number that we got from this, we use for predicting the motions of every planet in our solar system, as well as predicting the motion of projectiles on Earth. So when you fire a bullet, you use the same number that we measured here to determine that path. That's how we predict the path of projectiles and planets the same way. With this number that we measured, this force between two masses of known mass, we know how big these are, we know how much mass there is, We know how much torsion it takes. We know how much torsion it takes to twist this rod. We know how much force it takes.
You make an observation, you take a note, you write it down. If it happens again, if it repeats.
Yes, this repeats. Try it yourself, Spurs. Please go do this. How many times have I told you, Spurs? How many times have I told you, please answer this question. How many times have I told you, please go out and do this experiment yourself so that you can discover that we're not lying to you? I want you to go do this experiment. I don't want you not to.
I would have to go from the premise that something is pulling towards.
Go repeat this experiment, Spurs. Why won't you repeat this experiment? You can do this yourself. Look at that right here. This guy does it in his classroom.
You're not paying attention.
This guy's a freaking genius because he does it right here in front of you. He knows how big these are. He's got a laser pointing at a mirror on the bar. He knows how much torsion it takes to twist this bar and how much force it takes. Do this experiment yourself, Spurs. Quit being a little bitch and do it. For once. For once, do something.
This is how you measure gravity.
What do you mean this is how you measure
gravity?
This is how you
measure the gravitational constant of the universe with this experiment. Don't you get that?
Not really.
We're measuring how much force there is between two bodies.
You have to be on a board.
We're measuring how much force there is between two bodies.
Then you
Spurs, it all has to do with mass.
If you don't even know you're on a board.
It doesn't have anything to do with whether the Earth is spherical or not.
You deny gravity.
Has something to do with how gravity works. For this experiment, it is completely irrelevant if the Earth is round or flat or a cube or some weird hollow sphere.
Or spinning, for that
This
matter.
works under any condition.
Yeah.
Well, then this experiment is not necessary because all I'm interested in is if you're saying that gravity pulls towards the center of something, and the flat Earth.
Well, yeah.
Spurs, once again, back to the cell phone.
So again, what if you had? So this measures gravity, and gravity, and an object that looks like a sphere or has a spherical shape, in that case, the gravitational pull of that object acts as if it's pulling towards the center of the object.
Yeah, but you have to know if you want to.
They're two different things.
The Earth has mass, right?
What type of gravitation are you talking about?
Does the Earth have mass? Does the Earth have mass, Spurs?
It has mass, yes.
Can we show that mass attracts other mass?
Can you show that? Show us. Show us.
Spurs, she asked you.
No. Spurs, that was a direct question. Do you think we can show that mass attracts mass? Yes or no?
It is actually a yes or no question.
Is there an experiment that we can test to see if we can, like this ball has a certain amount of mass, this has a certain amount of mass?
Yes, you can do that.
So as we move them closer together, we can measure how much force there is between them. So we can do that.
Okay. Yes.
So the Earth has mass, and we can measure that mass has force between other mass. Newton's equation. Newton's equation of g times the mass of one times the mass of the other divided by the distance squared.
Yeah, but you would need to know how heavy that other object is. You need to know all
that's the point of this experiment. We know how massive this object is. We know how massive this object is. And we know how much force it takes to torsion that wire. How much to twist that wire. We've predetermined the force by measuring it. Okay? Now, if we know the mass of one body and the mass of the other, by moving them, by varying the distance, we can measure how much force that is and determine what the variable g is in that equation.
Okay.
We can determine g in g times mass of one times the mass of the other over the distance squared. If we determine g, we can now predict planetary motion. We can predict projectile motion on Earth, as long as we include things like air drag and things like that. But in a vacuum, all of our equations for that equation holds up for everything we do. It has predictive capability. We can predict what the surface of water will look like under a centrifugal force, like he demonstrated. That's what gives us that power, by being able to measure it. That's what this Cavendish experiment does and why it's significant. And you can do it yourself. like I've said, there's a guy like right here doing it. Shit, it was in the recommended. It's in my history at least. This guy right here, he does it. He shows you how to do it. And you can see him doing it. He knows how massive this is. He knows how massive the other one is. And when he brings in the weights, he gets a baseline, so he lets it settle on its own. He lets it stabilize. And then he introduces 2 bowling balls. And then lets it stabilize again. Taking all sorts of measurements, using the laser to measure that line. So he's never touching the thing, he's mounting a laser off of it. People do this all the time. You can do this yourself. So to deny that gravity exists and that we can't measure, and to say it's non-repeatable or observable, we're telling you it is, and you won't do it to go learn for yourself. To learn that gravity is a thing, and that we can predict just about everything from projectile motion to planetary motion, and far beyond that, believe me.
I think that guys are doing both a measurement of the actual gravity constant as well as an error analysis.
Credit to
And
this
actually,
guy.
his precision seems to be astonishing. That seems to be within 10%. That's really great for such a makeshift experiment.
Oh yeah, it is. Like you can go measure G yourself. Spurs, go measure it. Prove us wrong. Show us the error in the experiment where we're not seeing something.
How close was it he got to the value we have now? Wasn't like, what was it, 4 or 5% or something? It's really, really close. No, it's
That's fucking impressive with that setup.
Oh yes, it is. Because remember, you're basically measuring forces that are in our scale of magnitude. That's probably the smallest force that you can measure, and that's really great. And he's apparently got a statistical inaccuracy of 10%, which, I mean, you basically have to lock down the room to let nobody else walk through it and create some kind of wind flow.
Yeah, it's literally butterfly effect at that point.
Not really total butterfly effect, but just lots of statistical error. There might still be a massive systematic error due to, I don't know, the mass of the bar, the torsion constant of this torsion bar, and other stuff.
I got the joke, also.
Yeah, but for the purpose of the video, it gets the point across.
Spurs, are you still here?
And the math all proves it. He showed the math. The math supports everything. Like
we use
all the
math?
derivatives of the velocity versus the position and the acceleration.
What
all
I
of
showed was the Coriolis force, not
everything
the gravitation.
carries over.
If you want me to show gravitation, I'm going to need a lot more time and a little bit of time to explain quantum field theory.
I mean, I have a simulation of it going right now, so I mean, it's not very hard to understand either. This is a very... Basically, all this took was every single object in the scene. For every frame in this scene, the force between every object is applied. So I just iterate between every permutation of every single body in here and then apply the force between them using Newton's equations. I'm getting orbits. I'm getting the Roche limit where a body gets too close to its secondary orbiting body and tearing it apart. And that's how I've gotten these rings. So we're seeing how solar system rings can form. So when you look at Saturn, that answers that. Like gravity answers why Saturn has rings. So it's, when you deny all this stuff, it's a chain of denial of all sorts of different things that you don't even understand because you don't understand the simple concept of gravity.
An interesting thing, since Kara's showing this, is the fact that if you're making a game, right? If you're making a game that's supposed to behave realistically, you can not make the engine function without using gravity and the gravitational constant.
Nope.
And this is just a 3D scene. There's no trickery here. It's just 3D. It's everything here. I could essentially freeze frame and print out on a 3D printer with little rods connecting everything. Of course.
You can ask any game developer, and they like
it's just 3D. That's all it is.
Yeah, specifically the people involved in actually making game engines, and ask them to make a game engine that's supposed to function, if not identical, then close to what reality is.
Close enough that we can't tell when we play it.
Yeah,
it's called ragdoll physics.
Yeah.
Well,
ragdoll physics is something completely different.
Yeah, right. I was going to say ragdoll physics is something completely different. But again,
but the thing is, the reason I'm trying to make a point is that when the doll drops, it's going to behave in a predictable way.
Well, okay. So just because reasons, ragdolling is just how the skeletal model and what actually happens to a certain object, given a certain state, happens. That's ragdolling. It doesn't necessarily have to include gravitation in the game engine.
Yeah, but what I'm trying to use, for example, is if they take the ragdoll and they drop it, the ragdoll is going to behave certain ways in court when it impacts the ground.
If you want the actual the ragdoll itself to behave realistically, as in fall like a sack of potatoes, as if what would actually happen if you shot someone in the head, which you see on the movies where they just slowly fall over, it doesn't happen. You collapse like a sack of wet paper.
In the movies, they fly away.
I was showing us here now. Why can't we ever get video footage of what they're trying to show us?
Because of scale. This is very hard to demonstrate because gravity works at a very different scale than we do.
Basically, what Kara is showing here would take place over a few thousand or even 100,000 or even million years.
It was just a guess, yes?
Well, we can observe, like, if you look at ISS footage, experiments on the ISS, where there's zero-G environments, we do see a lot of this behavior, actually. We don't see gravitation because you need really big bodies, and it's hard to have a big contained space where things aren't going to be running into the walls or anything else. So we can't really give this kind of simulation, but we can demonstrate what a zero-G environment is, and we can demonstrate bodies attracting each other in a zero-G environment also. There's no reason we couldn't do that.
Yeah, a lot of scientists are running around trying to explain a lot of things when it could just be done by just showing us where we live, showing us...
Oh, fuck off!
Oh.
What do you mean?
We already did this hundreds, thousands of times.
Yeah, and we've already established that you don't know how to spot CGI from the actual thing anyway, so...
Spurs, if you want to sit there and shit on scientists, I suggest that you go and try and go to your nearest university and try asking them to show you what they do in a day.
Again, I'm not...
Spurs, how do you explain tides?
Science are only searching and
like everything here.
Science are only researching the model. This is completely different from going out there and researching.
No, Spurs, they're trying to refine the model.
Well, exactly, the model, not reality. That's the difference.
Do you see things like
Spurs,
this?
It is reality.
Do you understand what a model is?
Do you see things like this? This is reality. This is experiments being done in a zero-G environment. This is understanding how a film of water acts in a zero-G environment.
Unless you can create life, unless you can create this machine that you live in, how can you possibly...
You don't need to be able to create something to understand it. Or to look at it and know what it is.
No, you
don't. You need to create a ball, to look at a ball and know what it is.
Engineer things in order to
You have to be able to engineer a giant globe before you can know what a globe is.
Now who's in denial?
Spurs, how do you explain tides?
Stupid. You're in denial. The stuff you're looking at, you're in denial. This is real. You have to deny it because it defies your reality. Freaking child. You're in denial.
Actually, Spur, I would like to hear your answer. How do you explain tides?
Well, like I said, it have to do with the winds and the seasons and all these type of things. It's just normal. It's just normal. I don't understand what the
what kind of winds would create tides?
Winds and seasons.
If seasons were to create tides, wouldn't we have a high tide per year and not like twice a day?
Yeah,
You think about the wind. The wind on a flat Earth is just like a big tornado, but obviously you don't see it, you don't feel it. Sometimes it's stronger.
So it's Spurs. If we can't feel it and we can't see it, then according to you, it's not reality.
No, I said sometimes.
Spur, what you don't seem to understand, if the
My hat
tides
doesn't blow up every time I walk out my house.
Stop. Let me
Yes,
talk. Stop.
sometimes it does.
Stop. If the tides were dependent on the seasons, on the weather, as you said, we wouldn't get a regular pattern of tides identically every day. Don't you understand that?
You know what a tide book is, right, Spurs? You know how far those things go in the future?
Yeah, because the creator controls it. He controls how much tides go in, how it goes out.
No, Spurs.
wait,
you
stop
gave
a
weather. You gave no. Hold on. So you gave weather, which is unpredictable, and you gave seasons, which happen how many times a year? But we know that tides happen how many times a day? We know it's going to happen every day. Now we know it's going to happen every day. We know how high it's going to be and how low they're going to be.
Mm. Good.
And oddly enough, it seems to always coincide with the position of the moon relative to the Earth. I wonder
Coincidence about that.
It's a lot of claims, though, guys. That's all you've got. That's why there's no point.
No, we have reality, Spurs. We have reality. Right?
What are you showing us here, Kara?
And he ignores the whole fucking tides thing.
It's water in a zero-G environment.
Okay.
It's beautiful.
Oh, there's lots of really good stuff in
It's like
this.
the opposite of a bubble.
Yeah.
This is science. This is real science. We can see it. We can test it. We can observe it. What's the problem?
This is from the ISS, by the way.
I like this part.
And Spurs, we can test tides.
Oh, can you go back to the one with the CD player? That one is awesome.
Yeah, right after this. It's right after this, I believe. So like
That's
experiments
very
like this are
2001
showing you
esque.
objects in zero G. They're not attracting each other because they're not massive enough. They're only acting under their own inertia.
Oh shit! We saw a snippet of it. Does it come up later in the video where he makes a gyro out of the Discmans?
Even you can chime in, you know, mate.
Nobody's muted you.
Yeah.
Like everything about this is just perfect. Do you know how hard it would be to simulate, like to fake this?
No, we know how they do this.
How?
Please, how?
Jared
No,
hasn't
he's about to make the gyro now.
We showed the frog was floating. Remember that? Yes.
Hold on, we're talking about this first. I'll go into separate topics again.
Separate topic. The frog.
Yeah, you're talking about frogs.
You mean the video
Is there a
where
frog on
someone
the
put a
screen?
frog in a giant electromagnet and basically demonstrated that kind of everything has a magnetic susceptibility, but we only see it in iron because it's got a so freaking high susceptibility.
Well, and cobalt and nickel, obviously.
No,
Yeah.
I think he's talking about they actually had.
Yeah, they've had frogs on the ISS.
Ah, okay.
I'm not sure if it was the ISS or the other one.
It's one Earth.
I don't think they had. Oh yeah, it might have been Skylab.
But yeah, they had a frog in microgravity, and the frog didn't know what the fuck to do.
Yeah.
He just kept flopping around.
All right,
Yeah, he obviously panicked. That was unavoidable.
Yeah, I mean, it's something that doesn't have the cognitive ability to know what kind of scenario it finds itself in, so it just kept flopping about trying to find a footing.
So the point is, Kyle was saying that we can't replicate this on Earth. We can do what
No, we can't on
No, we
Earth. Do you know why? We can't do this on Earth. Do you know why?
We've just been speaking about it for the last 5 seconds. We're talking about the floating
We
frog.
can't do it on Earth. Do you know why?
We've just been talking about it.
Spurs, what's up with you answering questions?
We can't do this on Earth. Do you know why? On
Why is
Earth's surface, we can't do any of these experiments. Do you know why?
Why is that?
Because we
Gravity.
have gravity on Earth. When you're in orbit, you don't have that problem. You are in free fall when you're in orbit.
So what
On
is
Earth, you cannot do this.
So
if I can be a bit pedantic, the gravity is still like what 94% or something, but you have a uniform or you have an equal acceleration in all directions.
Basically, you have the centrifugal force of the ISS or the Skylab going around the planet very fast, canceling out the gravity. If you're taking a look at it from the ISS point of view, if you take a look at it from an inertial frame of reference, then the ISS is being accelerated downwards to Earth at the same speed as Earth is curving downwards. And as the ISS itself is not under any acceleration of its own, you don't notice gravity there.
Yes. That's just being a
pedantic.
But
you realize that we can use.
Dude, I'm a physicist. Being pedantic is my fucking job.
Spurs, you realize that we can calculate the orbit of any object we want around any other object we want, only by knowing the mass of the bigger object and the gravitational constant, and obviously the either the rotational velocity or the distance between the two objects. You know that, right?
Right. I mean, I don't doubt those things, but
do you know how this is done? Which formulas you need?
No, of course not. Like I said, my field is not like physics.
My field isn't physics.
All right,
as well,
but it's mine.
Dims
on the camera. Dims on the camera.
Hector, do us a favor and stay with circular orbits, okay?
Oh, come on.
Yeah, no. Carol, what is that in that bag?
Not a little piece of Lagrangian mechanics. Not just a tiny bit.
No.
No quantum.
Wait,
there's no quantum mechanics. Just the Lagrange mechanics. But anyway,
back to sixth or seventh grade physics.
Kara, is it
I'm gonna need 8th grade for gravity for that one. But
yeah, whatever.
Okay. Centrifugal force.
Spurs, this is reality.
Gravitational force, that's it.
Well, I'm not going to Hector's a very clever guy. He's studied for years. You know, he applies himself very well. You know, I'm not going to come and try and disrespect his art, his work. You know, and
it's not a fucking art. It's hard work and a ton of math.
You know, more power to him. But real scientists, Hector, you should know, by the way, go out in the field, and we're going to test your claim. Yes.
How do we know this? How do you think we know this math is accurate, jackass?
How does I'm not going to disrespect him immediately follow? But real scientists.
Yeah,
does it already count as a no true Scottish
I don't know how to say it in a polite. You know, I don't know how to say it without being disrespectful. Like I say, Hector here.
There is no way you can say it respectfully.
Oh, then I just won't say anything at all.
How do you think we got this math?
So, Spurt, do you understand what Hector's doing right now? What the two actual formulas that he's combining right now mean?
Hector could screw that up right now on screen, and Spurs wouldn't know what the hell how to correct it.
Yeah.
That is fucking easy. Any one of you could spot if I made a mistake. That it's simple equations.
Nope, it's correct. Actually, I had one physics lecture for my chemistry degree. It was in the first semester, and the calculation of the orbit of the ISS was the easiest question. Or the hardest question? I don't even remember. So this is shit you can learn, Spur, in like, I don't know, 1 week or so of lectures. At maximum.
With Spurs, no. Years. It takes years with Spurs. They would have to basically sit him down and force him to learn shit.
You could put Hector, you could put on the screen right now the physics equation of how to fucking burn toast, and you would say, Spurs, this is how gravity works, and Spurs would look and go, yeah, that makes sense. That looks right about there. That looks right about there. And he had no fucking idea what you're doing.
Spurs didn't leave that kind of impression, to be honest. But yeah, for a lot of things, it just needs somebody to tell you in a way that you understand. And I'm probably gonna piss a lot of people right now if I'm saying that you're fucking going at this a little bit wrong. A bit more calm, a bit more explanation, and just waiting until people understand and trying again. That's the most efficient way.
The thing is, we've dealt with Spurs before.
So much shit in the last time that we are starting to break.
I
at
know
least
it
I am.
can be exhausting. I know it can be frustrating, and I know at some point your nerves are just lying blank, and you
think you
really
could
have
change
the
that?
urge to just
The
reach
thing is,
out
we've
to
dealt
your
with
screen-
Spurs
to your
before.
screen
Yeah.
and
I think you
punch
could
the
change Spurs,
people,
honestly.
the person on the
Do
other
you?
side in the face. Please resist that urge, because
Hey,
if you don't
Hector.
resist that urge, you're not going
Hey,
to
we get your point,
rant
but
over.
hey, okay, we get your point, but the thing is, Spurs is not gonna learn.
Are you sure about that?
Yes.
Yes.
I'm certain.
By the way, Hellsoy, I lost.
I kind of wish I didn't call it off.
He can't learn.
Hey, Hector, I'll give you an example about this. Hector, I'll give you an example of this. I have been to Antarctica. May 17th, I'm going back down there. Last time I talked to Spurs about this, the first thing that came out of his mouth was, I'm a liar. This is the mentality you're dealing with.
That there's no Antarctica because that's either off the edge of the sphere of the Earth,
Yes.
or the US is going to shoot you down with their fleet of
behind
boats.
the ice wall. It's definitely behind the ice wall. Don't forget that.
Yes, but my
there's a
point
nice
is, you're not going to teach
explanation.
Spurs anything because he doesn't want to learn.
Again, I'm not going to be convinced of it until I feel it myself. And
So-
I'm probably gonna hate myself for going that far at some point, but I don't care because I know that's the right thing to do.
Oh, have fun with that.
Steven, what you
I
got?
more or less-
probably not, but I'll find out anyway.
Good luck to Spurs.
Well, I have the
because
same mentality, but there's a limit where I break. That's my problem.
Yeah. On the other hand, I'm kind of playing with the thought of one day becoming a teacher, and if this is not a good exercise in patience, then I don't know what is.
the ultimate
Yeah, it's,
test
what
in
do you want to
patience.
teach?
I don't think you could find a more.
Well, take a guess, Alex.
I think if you manage
Yeah,
to teach
I know
them
what,
something,
but what kind of students?
I've got no fucking clue.
if
The
you
smart
manage to
ones or the
teach them
retarded
something,
ones?
oh,
But anyway, Spurs, any question? Let's just explain what I just did here. For a satellite in orbit, as seen from our rotating frame of reference, who's building with a pair of binoculars there?
Steven, introduce Steven. Come on.
Okay. Ah,
Experimenting
nice.
around with the gravitational sensors. Okay. Anyway, back to orbits. Law of gravity, centrifugal force. You know, the thing that that I had to leave out of my calculations before to make it a little bit easier. I'm not going to go through how you calculate that. That's going to take a little bit more of time. For now, you'll have to believe me on that one. Gravitational force, basically the formula that we've got out, and I made a writing error there. In order for something to stay at the same altitude, not being accelerated upwards and downwards, the centrifugal force and the gravitational force have to be equal. Put those in. Both have a factor of m1 on both sides. You can cancel that out. Multiply both sides with r squared, which means the r squared from down here cancels out to 0, and the r here turns into a r cubic. So we end up with the third power of the radius of orbit of our whatever is in orbit there equals the gravitational constant times the mass of the object that we're orbiting around, divided by the square of the rotational frequency. This calculation can be used to calculate the orbit of any stellar object in the basically our entire universe in our solar system, and we've punched in the orbital radius and orbital frequency of all of the planets in our solar system, of all of their moons, of our moon. We tested it, and this formula yielded the correct result every fucking single time. This formula is based on our understanding of gravity. If our understanding of gravity were wrong, then there had to be some situation where this formula would be wrong, because what we based it would be wrong. But it isn't. And the only conclusion that seems to result from that is our understanding of gravity appears to be correct. End of lecture.
Do you understand that we can plug this equation that Hector was showing into any planet-moon system in our solar system, and whenever we do that, we get the same value for G. Do you understand that?
Yeah, I understand what you're saying. I hear what you're saying. Absolutely.
Nice. Okay, thanks. I just wanted you to confirm it.
Here's a tricky question for him. Could you plot all the stars onto the inside of a sphere?
Hell,
You push
I'm trying to get an answer to my sexting question, but I'm not going to go there right now.
True.
I don't think I've ever actually used a sextant.
If you wanted to map all the stars out, what would be the best way to do that without having any distortion? Would a sphere be useful? Spurs. Keeping in mind that all the planets are among these stars, and their relative positions are among these stars. And everything we've just said is contingent upon the fact that all these stars are in a three-dimensional distribution in all directions around us. So they all have 3D coordinates at some point in space around our sphere. And we can use very simple geometry to determine the locations of planets relative to our current rotation and our position in orbit around the star, our sun. This is all very simple if you understand the system, because its predictive capability is unmatched. Nobody's been able to reproduce this in any other way than to plot it out in 3D space.
It's still a theory. It's still an idea, and still we can prove it 100% fact.
It has been proven 100%. It's in reality.
So answer my question. Can we plot the stars into a sphere around us?
I can't. Whether you claim you can or not is a different thing.
Why can't you? Why can't you? I'd like to know why don't you think you can do that? Because you can.
Because I would need to
I could show you a
go.
protractor with a straw on it that you could do this with.
I don't know what the stars are.
We do.
Or where they are.
We do.
You can locate them though, right? You can look up and see where it is. And you can locate where it is in the sky, right?
You make your claim and we test it. That's all.
Yes.
It's not my claim.
That's
It's
all.
a
We
fact.
just test your
It's a fact.
Can you measure where stars are at?
Can you do this? Can you do that? I'm not making those claims, Kara. No, I can't do anything unless it's within my, arm's length.
Yes, we're making the claim that the Earth is a globe. Will you actually go out and confirm it for yourself?
Right. We will test that.
Will you go do that?
Absolutely.
Will you?
I've just said absolutely. We'll test that. If you're saying it's a
Who is we, Spurs?
Will you plot the stars with me?
Plot the stars?
Will you help me plot? Will you help me map out our hemisphere and map them to a sphere? Will you help me do that?
There you go again by talking about the stars. First, we need to prove the ball.
Yes. Let's map the stars. Let's map everything around the Earth. You know how we could do that, Spurs? You know a great way we could do that?
You want to map the stars or prove the globe? Which one?
I could show you how we could do this.
The Earth has been proven as a globe, so you can stop with that argument.
I'm saying, which one do you want to do first, the globe or the stars?
The globe has already been proven.
If you want to,
I'll show you how to map the stars, Spurs. It's using the globe.
No, you can't do both. That's the biggest.
Yes, you can.
I sure as hell can.
Well, make the claim, and then we'll test it.
I can
who
map
is we,
the stars
Spurs?
easily.
I'm saying it can't be done. So you've made that claim that it can. Make the claim.
I'm saying it can.
We will test. Yeah, I've just said we will test whether what your claim is true or not. That's it.
It's we have mapped the stars, Spurs.
You know what you need to do though? You're gonna have to rally up all your little flat Earth friends because I have a little experiment for everybody. It's very simple.
Go on.
The experiment is all you have to do is take a camera that you're capable of taking a picture of the stars, as long as you can capture at least the significant ones so that we can figure out their position. This is what you do. You take a picture of your zenith point. You record your time and date. Done. Submit that picture. I don't need your location. I don't need it at all. I need your time and date. That's it. Take a picture straight up. If it's taking your phone and laying it flat on a table and pressing the shutter button. It can be that simple. Lay it on a flat surface that you know is as level as you can get it, and take a picture straight up. And I will show you. Get me 100 pictures, and I will show you. And I will map the stars for you, Spurs. 100 pictures from 100 locations, and I will prove it to you. I know there's more than enough flat tards all over the world, and I can prove to you that you can map the stars, and you can thus map the planet Earth at the same time.
Then, you know, if that's what you're saying,
Come on,
that's how you
Spurs.
prove
Take my offer. This is an experiment for every little flat tard out there.
You're missing the point, Kara.
No, I'm not. You want to do observable and repeatable experiments. I'm giving you one.
Can we map the stars? I said
giving you
no,
one.
we can't. You said
Wait,
yes.
I'm
Why
telling you
can't
we can.
whoa, why can we not map the stars?
Why can't we map the stars, Spurs?
You said yes, we can. Because I wouldn't know how
Yeah,
to
let's map the stars.
Oh no, not you, just anybody. Does anybody have the ability?
First, good news. You won't have to map the stars. Kara said she's going to do that for you.
I'll show you.
To know how
I'll
to
show you everything I do.
When she's mapped the stars,
I'll show you every little thing I do.
her claim
Promise
will be
you. I'll do it
That's
all
what I
live
said.
on
No.
ED.
everything that you ball earthers say. We were going to test. That's it. So I don't know what the argument.
I want to show you.
Yeah, go ahead.
Yeah,
And if she did her work, then go test it.
Do what you do, like Hector.
I've just made the claim. You're gonna have to help me, because I'm not gonna do it without flat tard help. Because if they're not willing to do an experiment, fuck them. Okay? Because if you don't want to do an experiment, to do something to look to observe the world around you, and to at least try and map it. Like you want to make a flat Earth map, this is how you could do it. This is a way you could do it.
No model can be created. I told you that. Like all
That's
globes.
bullshit.
Bullshit.
Doesn't matter.
Wait, what?
You have to be the creator in order to
That's
make a model.
bullshit.
Bullshit.
You're full of it.
Yes, Hector,
This is what he
we deal
does.
with.
This is what he does.
How can you model a system?
He will stoop to any level to deny what you're telling him
How can you explain that to me? How you can model something you didn't create?
by mapping it.
Oh, it's
A model is called a model because it's not the original. A model is basically a copy.
But it's
so
not.
essentially what. So let's put this to an actual practical example. This means that we wouldn't be able to make and understand how a car works unless we're Benz.
Unless what?
Unless we're
Mercedes.
No, like
not at all.
like the actual. We're
You
talking
mean
about the
Carl Benz,
person.
the inventor of the car.
Oh.
Yes.
Yeah.
Yes. So it's
no.
impossible for anyone to make a model of how a car functions unless you're Benz.
No, you need to know how a car, not the name of the car, just the machine.
No, that's the name.
Now you change the argument.
Fuck sense.
Yeah.
That is the name of the inventor of the car.
So
He's
we're talking
the
about- we're talking
creator
about-
of the car.
We're talking about the model of transport, moving somebody from A to B.
Car.
We're
We're talking about a
the
car.
functionality of the car itself, how the car itself works. You're claiming that if we are personally not the inventor of the vehicle, of the car, then we can't make models to describe it. For example, how the engine works, how the transmission works, and so on and so forth.
Yeah, how the drivetrain works, what the brakes do, how they function.
Guys, before we start the rating here,
Right?
the claim wasn't
anything
that
that
she's
man-
going to make a full
When we
copy
say the
of it.
words man, that means any man or woman can create it. If it's God made,
I'm just saying we
nobody.
can measure conditions.
Nothing
Things.
is
Do you think
God
that's
made.
The
possible?
claim was not that she would make a full-on copy of the entire heaven, just that she would create a map of where the stars are in the sky, not like create a copy of every star in her pocket or in her room for you to then take a picture of. Just a map.
For example, wait, stop. I live in a house that I didn't build myself, right?
Mhm.
There it is.
Can I make a blueprint of it?
Hold on, what's Steven saying? Screen share, Steven.
That's how you do that.
Wait, what?
He's showing you the moon.
Did you
Or
just tape your phone to your... Hey, that's cool.
Hey, it's
I
actually a
think
rig. You,
Oh,
Definitely.
I'm sorry. Was somebody wanting me to go look for some curvature? Did somebody say P900? Oh, I'm sorry. Did somebody want to have a distance contest? Because I'm running about 25 over here.
Oh, that's the
Um,
kind of MacGyvering that I really like.
So, first, again, my question. I live in a house that I didn't build myself.
Mhm.
Can
Does
I
it
make a
matter?
Can I make a blueprint of it? And by the way, the house that I'm living was bombed twice during World War II. Every wall is different. Can I make a blueprint of it? Nobody has the original construction plans. Can I make a blueprint? Yes or no?
Of course you can.
Yeah, sure. Right. And that's the same thing that Kara is doing.
No, it's
Or is
not.
planning to do.
The
Yeah,
creator
yeah,
of
it
the,
is.
she's
It
not the
is.
creator of this system. Man can build a house. That's possible. It's man-made.
Okay, then not a house, let's say a cave.
Let's
Let's
say
say
if
I live
Clara built something
let's
and
say
you
I live in
couldn't,
a cave.
and that
Can I
would be
map a cave?
something
We're not
significant.
asking Karen in her pocket.
What?
Cut out.
Christ.
Sure.
I just cut out. What was happening?
I
I said we're not asking. We're not telling Kara to make stars in her pockets. Making stars and making maps of stars are not the fucking same thing, Spurs, and you know this.
Well, it's like this thing right here I have in the scene is technically a map of the stars. I can use this. I can find Orion in here. I can find the Big Dipper. I can do all that. And
I
I can
wonder
use
how
it.
Spurs thinks
So it's
normal
like-
maps work, like land maps.
Spurs,
It's like
what
you
she's
look at
trying to
direction,
do is
look, there's
basically
Orion right
nothing
there.
different than what you do to make a map of the Earth. You can
Yeah.
make a map of the Earth by basically flying
every
high up
star
with a
you
plane and
see,
taking a lot of photos.
What's the
And
problem?
and then afterwards putting these photos together like a puzzle. That's one way to make a map. And what she's trying to do is just make the same thing, but not for the Earth, but for the sky, taking a lot of pictures, putting them together so they fit, and by that create a map of the stars. And you can create a map of something that was created by God or whatever other divine being you want to claim.
Oh, of course. That's different. That's different. Of
No,
course.
Yeah, and
Oh, here we
she's
go.
going to create
No,
a
it
map
isn't.
of the sky.
Yeah, that's
That's-
different. I didn't know you were talking. We can observe the stars, so of course we can do that. Yes.
Oh, gee.
Good. Great that we've got that out of the way.
How fucking dense are you?
I think it's less being
more
dense
question
and more of
for-
having a tendency to misunderstanding things, which can be annoying. I had that for a while.
No, it's
Can be
when
hard to get
Spurs
rid of.
changes. Spurs fucking shifts the goalpost. He'll play the game of I don't know, and then when he gets cornered, he'll go, "Yeah, I knew the whole time." He's done it before.
Look, we were talking about globes and stars. I said to her, "What do you want to sort out?" The globe.
And he's going to change the subject again.
said,
We've
"I want to
established that, well, you can map the stars. Kara's gonna do it. If you get a few friends of yours to take
Yeah,
a
what's
picture
what's
of
the
the
problem with mapping the
stars with the camera perfectly facing
What's the big deal?
upwards.
Can she take a picture of the globe? No. Can she show us a rotating ball? No.
I can.
Oh, go on. Let's
And
see
it's been
this.
done. And it's been done.
The
Show me a
Foucault's
rotating
pendulum
ball.
experiment is planned for the weekend after the coming weekend. You're perfect. You're invited to join me. If you want me to pick you
So
up
you're
from the
saying
airport, I can
that your
certainly do
balloon
that.
will show us a rotating ball, yes?
Yes, what I'm going to do, show the rotation of the
Good.
Earth.
I can't wait
And
for
if
this.
you
We've got
get a few other of your
some-
friends to repeat the experiment, I
the
can prove
boys,
the curvature
all
of
the
the Earth.
Earthers, we're going to have a big gathering. You're going to show us here too. They're going to show us a rotating ball.
No, that's not what Hector said.
Yes?
No,
What I said was, I
Hector
can.
said the
with my-
rotation, not the rotating ball in its entirety.
Alex,
He
Alex,
was
I'm
just
gonna say what I
talking about-
said.
Yeah, okay, right. Go on.
My Foucault pendulum, standing on its own, only proves the rotation of the Earth, not the shape. What you need to prove the rotation of the shape of the Earth as being a sphere is multiple Foucault's pendulum experiments executed at multiple latitudes. If you're gonna give me camera rights, I can show you how that works. Camera on. Now, You remember that the Coriolis force was this thing with the cross product.
I think we're asking too much to ask for to see a rotating ball. You think we're asking a lot?
You have it if you look for
not
it.
a lot. However, basically you remember how the centrifugal force was
a real rotating ball. Because I don't know if we're asking too much or if it's difficult for them. What's the problem?
I'm going to tell you what the problem is. You know, hold on.
Hector, hold on a second. The thing is that the Spurs, what Spurs is trying to say is you can't take a camera out in space and take a picture of the Earth as it fucking rotates. That's a game he's going to play with you. Just let you know right now.
I sadly can't because I don't have a private space program. However, I've got tools that can prove that the same thing. However, that aren't as obvious to, that are.
I know this, and you know this, but the thing is, Spurs is going to play this little game with you.
Yeah.
Well, what about Stephen? Stephen's in the same position, same boat as me. So it's not just about Spurs. Millions of people.
Right now, he's not talking, is he?
He's doing observations. That's why.
Well,
observation of what?
He'll tell you his final
right.
returns, and he'll give you.
You remember how we proved the Coriolis force to be of this force, have this equation on the page before. Now, cross products have a interesting property, and that is that the length of the vector that our cross product yields equals. Hold on. Basically, if we've got our vector omega here and our vector r here, then we've got an angle between the two of them. I'll just call it angle alpha for now. And the magnitude, and basically the length of the vector, these bars denote the length of a vector, is, that's a sine of alpha times the length of omega times the length of r. And in essence, when we're conducting the Foucault pendulum on our Earth, the let's say this is our Earth. Yeah, that's in the picture. That's not to scale. The Earth isn't really that wonky. This is our rotational axis, so we're rotating this way, and we're executing the experiment somewhere around here. In that case, the angle alpha is this one, due to how exactly the Coriolis force works on our Foucault pendulum. This means that basically what we're trying to measure with the Foucault pendulum is that if we were to execute it on the North Pole, we would see the plane of rotation of the Foucault pendulum turning around once in 24 hours. If we were to do it on the equator, we wouldn't see anything. And in between here, we will have a dependency on the sine of the angle. And what you need to show for the Foucault pendulum to prove the rotation of the Earth is to prove the dependency of the rotational speed of Foucault's pendulum on your latitude. Because essentially what you're measuring with the latitude dependence is the angle between the rotational axis of the Earth and the ground. And if you prove that the ground is at this angle to the rotation of the Earth at this latitude, and at that angle to the rotation of the Earth at that latitude, you've proved the curvature. And this is how you can use Foucault's pendulum to prove a curvature of the Earth, and by that, a round Earth.
Bravo, Hector. Bravo. That's very good. I like your presentations. Good stuff.
Thanks.
Good work.
So, Spur, would you accept that if we had like six or seven people on different latitudes doing this, would you accept the results?
Absolutely. Look. As I said, everything, all these claims that are on paper, you have to take them into the real world and test them, and then you verify them. That's it. It's not a problem.
Okay. Are you going to put the Foucault pendulum then? Because that would be really great. What's your latitude, if I may ask?
You lost him at latitude.
Yeah, I think you might have to explain what latitude is.
The degrees north that you get when you zoom in onto your house on Google Earth.
Like I'm going to tell you that.
We're not asking for your position, where you live, your latitude.
It's impossible to figure out where you live by your latitude alone.
So, judging by the dialect and the time zone, you're in Great Britain, so it's between 51 north and 59 north.
Yeah, like I can give you mine. I'm at about 60.28 or whatever.
We're at 49 and a half, me and Hector.
Come on, Spurs.
What's wrong? What's up?
All you gotta do is go Google Earth and put a little fucking place marker. It'll tell you your position.
Oh, fuck's sake. Give me a second.
If we were to know your place marker, you need to both your longitude and latitude. That's if you were, and you can also say that basically you're going to round. You can also round it to
half a degree
take
or
a look at Geo's live stream. There's a scale of 50, 51, 52, and so on.
You see that here? Yeah.
I'm at 60.44 actually. I had to correct myself.
Let's
60.
see what am I on.
Oh,
Yeah,
that's
here,
quite
right?
north. So
You will get the best results.
at 60.44, I'd expect a full rotation in 27 hours. So that would be 13.0 degrees per hour. That would be quite well measurable. I don't know about postage, but if we're done with our pendulum experiment, I could send you my construction, so you can execute it.
Yeah, I do it.
Actually, Hector, we can send him the experiment itself.
That's an expensive package.
Yeah, because basically I've at the construction market, I've bought 12 stones that are probably going to add up to 20 kilograms or a little bit more of weight.
I don't think you have to send the stones, just
No.
the pendulum.
I would
I
just
feel
need to know the exact weight.
Yeah, the thing is, I'm going to build the construction around the stones to suspend them from a rope to the exact measurement of the stones, and I'm planning to weigh the individual stones to see how heavy each one of them is, so I can balance it out so it's not heavier on one side than on the other. I know
Like I
I'm
said,
pedantic, but again, I'm a physicist. It's my fucking job.
You know, if you can prove curvature, if you can prove then you've got no argument, Hector. You welcome it. You know, you welcome it if you can prove any of those things. No one's going to argue with you.
You will.
Me.
Yeah.
Bring us the evidence. Show us that we're spinning. Show us curvature, and everybody's happy. Yeah, Globebusters.
Plenty of people have
An
already
experiment
done
will be
that.
happy.
Everybody, we'll all shut down, go out and go back to the regular lives. We'll
I'm going to
continue.
take
So,
you by your word for that.
absolutely, if you can prove that we're spinning, and you can prove curvature.
We're rotating.
Good night, Vienna.
So, Spurs, what about my experiment? I think you didn't answer it before.
Same goes for you, Gio. If you can prove those two things,
No, that's not what my experiment is about.
that's it.
What Alex's
Or what do you-
Alex's experiment is about is measuring the curvature of the Earth, not its
Directly.
rotation.
Obviously, you're
What
going-
I'm doing is measuring the curvature of the Earth indirectly through what it does to my measurement of the rotation of the Earth, because the curvature of the Earth is going to distort my results. And as I can measure those distortions, I can then trace it back to the curvature of the Earth. What Alex is doing is directly measuring the curvature of the Earth by, well, basically flying very high up and seeing if it
Hold on,
curves.
who's doing the rotation then?
I'm the guy for the rotation. Alex is
You're
for
the-
directly measuring the curvature.
Great. Great. That's what we wanted. That's what we've been asking these globers for the longest time.
Do you accept
Yeah, but
his
we are
experiment?
not the first guy to do. We are not the first guys to do it.
Well, like I said, you bring back the sufficient results and they'll be accepted by the community, no problem.
It's already accepted by the globe community.
Listen, guys, we can sit here and just fight about how
Oh, it's
whether these things have been proven or not. And
Everything will be
I have-
verified.
I've
Everything
got my view on those things, and I'm not going to spout it here because it's just going to lead to more screaming. We're probably not going
I'm
to
trying not to really argue with boys
that
because
we
like I
don't need to do that because it's been done before. So
said,
I'm going to do my
evidence and-
Foucault pendulum. Alex is going to do his balloon. We're going to present the results, and I'm quite certain that we're going to convince some people. And if not, then we're definitely.
No, but yeah, that's
call some
right.
people
That's
hypocrites.
right, Hector. It's all about convincing people, changing minds, waking people up. Like if you think it's not flat, wake them up. ability.
Yep, that's why I'm here.
Exactly, yeah.
So
But-
Spurs, you approve of their experiment? Do you
I
approve of their
approve.
methods?
Yeah, we will check the claim, Cara. That's what we just said. He's going to show us his
You
results.
approve of the methods that he's using?
He can use whatever methods he likes.
Do you approve
If
of
he
them?
proved-
No. Do not just say I approve of any method anyone else likes.
If
Take a fucking look at my method, and if something's wrong with it, then go fucking tell me, because I want to be right.
That's what we
And
just said.
that's how science works. If someone were to use a wrong method to show something,
So
then
you're
of course
okay
you're
with
going to
that?
get a fucked up experiment result.
I'm saying that anybody can use any experiment. If you're going to use this experiment, fine. If this proves curvature and you show rotation,
Do you think it proves
that's no
curvature?
problem.
Do you think it proves
Well,
curvature?
how do I
And
know?
if
I mean,
not,
if
why?
he got those results, if he gets the results that he's predicting, if the Earth was a sphere, then what?
Well, if he proves it, what are you arguing with?
We're just
So when
we're
it comes
not arguing about
back
anything. We're
with
just
the right
seeing if you
results-
accept his method.
Whatever
But
method he likes.
do me a
I
favor?
can't tell him how to prove the Earth. It's his choice. He's
What
going
proves
to.
it for you? Is it valid for you? And if not, why?
The answer will be valid. Well, that's what will be valid. That's what I would. I don't know his answer yet. I know how he's going to do it. But if he brings back
You know, it
curvature
answers a
and
question
spin,
here.
that's fine. There's no problem.
For example, Spurs, are you going to bitch about Geo's camera on his balloon?
Yeah, let's say that I'm using a GoPro, which I'm
Look,
not. But
you don't know
wait,
the results.
that is a
We don't
that is
know.
a direct question.
Yeah, but how can I know until you give me the results?
Because I've shown you the methods that I'm using.
It's called a hypothetical.
Yeah, you can use whatever method you like. Just bring back the results.
Goodness.
Yes, but you're going to say his camera has a fisheye lens, so it's invalid. There you go.
The thing is, I've designed the experiment so that the lens of the camera is totally irrelevant.
Yeah, but at Spurs, it'll be relevant.
Yeah, probably.
Well, in that case, just show them the results, and if some people start bitching about stuff that doesn't have any effect, then we're going to have a good reason to call them hypocrites, and, well, then I'm going to do that. And then
By
I'm
the
going
way,
to be the guy who says, fuck this shit, I'm out.
I 100% agree. If you show a spinning ball, people deny that, then they're absolute hypocrites. Absolutely.
Do you approve of his methods?
He can use whatever methods he likes.
That was she
can't tell
asked.
him-
Are they
I
the
can't-
methods you would use if
I
you were
can't-
trying to do this experiment?
Sarah,
I can't tell the person how to operate.
I would like him to answer. It's like he
But
never
I
answers anything.
can't tell you how he should gather his information, can I?
Actually,
You're not telling
sort
him.
of
You're
good.
asking me, do you approve?
Well,
There is no opinion on that. That's his
Yeah, it
method.
is.
No,
There
he's
is.
no, they're asking if you think his method is valid, if you think it would work.
And if it's not
How
valid,
can I
the
have any-
question
I-
is,
I-
what would you,
Uh,
what would it
guys,
take for you to make it valid?
One second. You're asking him a lot about whether he thinks my method would work. I did not really go in depth about what exactly my method is going to be in the Foucault pendulum. I just went through the math, not through the construction. If you want to, I can go through how I'm going to construct the Foucault pendulum if you want, so that you all.
Sure.
All
Oh,
right.
yes, please.
How tall is it going to be? Hey, details.
I'm going to be in the staircase of the house in Nuremberg that my grandmother is managing. We've got a total height of 14 meters available, and of that we're probably going to be using 13 meters because we can't go all the way to the top, and at the bottom we're going to need a little bit more place for the scale. I'm going to build a wooden construction, which are going to hold, which in its center is going to hold a small wooden block with a laser pointer attached to the bottom of it. The wooden bar in the middle will be held by 4 adjusting screws and 4.
It helps
What again?
Spurs to have pictures, if I might suggest.
All right. Okay. So basically, looking at it from the side, I'm going to have. Hold on. New page. All right. Top view, I'm going to have 4 piles of stones. And in the middle here is going to be a construction with a laser pointer, which is going to point at the ground. This is where I'm going to exactly know where my pendulum's at, hopefully to be within 1 or 2 millimeters of positional accuracy. Now, side view is I'm going to have 3 stones on top of each other. And basically here, this is the line. A wooden board with a hole in the middle. And in the central hole, there's going to be place for a wooden bar with a laser pointer at the bottom. This wooden bar will be adjusted by screws, 1 pair of screws at the top, 1 pair of screws at the bottom. This will allow me to adjust the bar left and right and in regards to angle, so that the laser pointer is going to point directly at the bottom. I'm going to align the laser pointer by taking the weight, rotating it slowly, and seeing if the laser pointer at the bottom is going to draw a small circle. If it does, I'm going to readjust the laser pointer until the circle is gone. I'm going to do that at different distances of the weight between the weight and the floor to make sure that the laser pointer is not going to point sideways and just happen to cross the floor at the middle of everything. Now, for measuring the actual shift in the angle, I'm going to use 2 scales, which I'm going to glue to the floor or just attach with duct tape. Probably these cheap paper scales from your construction market. And I'm going to measure the distance between the 2 of them. And as my pendulum is going over them first from this to this, I'm going to measure the positions at which it crosses those scales every few minutes or so. I mean, every 5 or 10 minutes. This is going to give me a few data points. The problem is I only have about 20 centimeters of space available. So I have to be very accurate in how I measure these the position on those scales. And this also means that I'm probably only going to have 2 or 1.5 hours of time available. So I'm probably going to reset the experiment a few times. I'm hoping to get about anything between 20 and 50 data points. This will allow me to go to do a statistical analysis on the statistical error. And then and afterwards, I'm going to check for any systematic error that I might have.
If I may, I just want to give you a tip for how you can attach those things to the floor.
Yeah.
So there's this neat trick with hot glue that if you use rubbing alcohol on it, it actually loses its bonding on anything but itself, and even to itself. So you can hot glue it to the floor and just use a few drops of rubbing alcohol, and it'll like just release.
Okay. Thanks for the tip, but I think I'm going to resolve to duct tape because the floor I've got available is massively solid tile floor. That thing survived 2 world wars. It's gonna stand through a little bit of duct tape.
Yeah.
And also, I'm going to put a carpet underneath all of that, which I'm also going to fix to its spot with duct tape, for the simple reason that if my wire were to break, I don't feel like ruining the floor of my grandma's house.
Good point.
Details.
Yeah, I've also got some very thick carpets available.
Well,
gotta remember not to step on them a lot, so I don't move the scales.
I think the lesson here is that you should try to avoid doing accidents during experiments unless there's a chance of them giving you superpowers.
When are you planning on doing this?
Current plan is the weekend after the next one.
So
However,
2 weeks.
that's also the time when the semester starts. So just in case things go really wrong, it might be delayed by another week. And in case I run into some really massive trouble that's really giving me something I didn't expect and I don't know what's going to happen, then yeah.
If we can coordinate it, would you like to me be record at the same time you're doing yours, the pendulum at Griffith Observatory?
The time at which you conduct the experiment won't matter at all.
Okay. So next time I go up, I'll just film it for you.
All right. Yeah. The ideal case where if I had a wider staircase available, or just if I had just some big kind of tower or church tower available, where I wouldn't need to reset the experiment. But yeah, can't have everything. But I got to make do with what I've got. So
I just hope you get the right results, Hector. You know. I'm rooting for you. I hope you come up with the. I hope you can verify and give us what we need. You know.
Yeah, I'm working on it.
So what do you think of his method now that he's explained it? Are there
Well,
any problems?
all I can say, if it works, it works.
So there's no problems with it? You don't see any issues?
I said there is no opinion. I don't think you understand. It's like me telling him how to go and do research. It's however he brings back the results.
That's how science works.
If you see a problem with
basically
his
was
method,
first saying, well, he doesn't see any problem with it right now, but also he doesn't really have a lot of ideas about what might go wrong and not a lot of experiments in science. So he isn't going to definitely say, yes, this is okay, because he's not really certain.
different
right?
if he said it that way, but he doesn't say it that way.
Yeah,
He
you're
just
not-
says
gonna
any
get-
method you do is valid, and we'll just evaluate it after the fact. And I suppose,
Yeah,
Look,
that's
sure.
also.
experiment
Yeah,
suppose
but
sure, but
in order to prove something, to prove a claim. He's claiming that the Earth is spinning. He's claiming that the Earth has curve. Well, then all I can say is, well, you know,
Can it-
I'll welcome the opportunity to receive that information if you've got it.
can it be shown with the pendulum? Do you think that's possible?
Again, his method, you know, is
Do you think
whatever
it
he
can be
wants.
shown with the pendulum?
I don't know. We'll see.
Well, if he gets
I don't know.
conclusive results that yes, you can, do you think it was possible?
let me
Okay.
ask it this way.
Look,
If I can prove the rotation of the Earth, are you going to accept that?
absolutely.
Thank you. That's
the
all
pendulum?
I'd ever want to know. And I think if we just keep insisting on say this, say this, say this, we're probably not going to get there. We've tried it for the whole evening.
We know who we're
Well,
dealing with.
some-
That's the reason why we want exact answers from them.
Calling
It's
it right
something
now.
I want
is
him
like
to do
anyone does
because
that.
to him to admit, because as soon as you do this, he's going to say, "Well, how do you know a pendulum is even showing us that?" He'll jump to the next level up and
Yeah.
just deny that instead.
You'll find
So-
any way to refuse the data.
So you have to get him. You have to pin him down to a position, otherwise they'll dodge, and you'll never get them to agree to anything. As soon as you do it, they'll deny it.
Kara, what do we ask for? We ask for proof
Evidence.
of a spinning
Yes.
ball.
What's
And
interesting is the point
Okay.
where what
how
proof will
you
you
decide to
accept?
go about it is your doing.
What
Spurs,
proof will you
Alright,
accept
Spur-
is the problem.
Let's go it this
And we
way.
will tell
There's
you
something
if-
inside that's called a certainty test, which is basically we've got basically in this case we've got the claim that the Earth is spinning, and I'm going to do a measurement, and this measurement is going to result in a certain value. That value, I'm going to have the value, and I'm going to have a statistical deviation, basically an inaccuracy of that value. I'm expecting to measure about 11.5 degrees per hour of rotation.
It's like you're trying to tell me what method I should tell him to use.
And now, my question is,
all I've asked for is proof of a ball.
Spurs, listen to him.
Spurs,
proof of
and
rotation.
now such a certainty test, for a certainty test, you usually say, okay, when you get a result within that range, I'm going to accept your thesis, and if you don't get that result, I'm going to reject your thesis. What are the borders that you would set me if I expect some 11.5 degrees?
Listen to what I'm saying. Prove the Earth is spinning. Prove we have curvature, and then you have no problem.
Oh, Spurs,
All right. So the two things that you say I have to
Again,
prove
you're
to
going to ask me, how do you want me to prove that?
Hector, can,
No, no,
can, I,
it's
can I
important.
point,
The
can I
method
point
is
something
important.
out?
If you think you can prove it, if you open your mouth and say, yeah, I can prove it, then go ahead. I'm not going to stop you.
All right.
Hey,
So
yeah, you will.
if I
Can I point something out, Hector?
Yeah.
So Spurs, what he's actually saying to you right now, because you're clearly not listening, is
Mhm.
he's asking you to accept the fact that if he predicts a certain outcome and that outcome happens to be true, it's then evidence for his prediction based on his assumption that the Earth is spinning. He's asking you if you're willing to, if the outcome falls within the margins of error on an experiment that you would then accept that as evidence?
There are no theories on a flat Earth. So I'm only accepting.
Again, you're not listening.
I am listening, and I'm saying
You completely avoided it.
what I want, or what flat earthers want.
Again,
They want
you're
proof.
not
If any
answering.
person says,
Spurs, you're not answering the question. If not if when he does this, if the result happens within margin of error to the expected outcome based on his assumption that's based off of the model, will you accept it as proof?
off the model, yes, of course.
My goodness.
Okay, so you just agreed, just to make sure, you just agreed that if Hector gets a result that's within margin of error based on the spherical Earth model, that then you will accept this as proof that we're spinning.
Proof of the model is spinning, yes.
He's quantifying model now.
Okay, so
I'm not
by
talking about
model,
the I'm talking about the Earth spinning.
Yeah,
so
we're
that's
talking
what,
about
good, Hector.
we're talking about the physical reality that the Earth is spinning. Do you agree, given his results being within margin of error, do you agree that this is physical evidence of the physical spin of the physical object we inhabit?
We will see the results when he brings them.
That's not an answer.
Because I
Let me
can't
put
give
it
an
this
answer
way.
until I see the result.
If I show you a rotation of the Earth within the margin of error, will you accept that as proof of
I
this
would accept
Earth?
you. I mean, I'll
And
tell
if
you what I would
Alex
accept.
and if Alex shows you measures a curvature of the Earth within the margin of error, will you accept that as proof of a round Earth? Yes or no?
Yes and no.
No, Spurs,
Is
this is not how it
a
works.
valid answer.
No. So Spurs, you saying that we'll have to wait for the experiment is not how this works. You have a claim. You have a way of falsifying that claim. We're now asking if you agree that if the data corresponds with the claim, right, that would then validate the claim. We're asking if you're capable of understanding this and actually agreeing to the fact that if data represents prediction, then the prediction based off of a model is correct.
Yeah, sure.
Thank you.
Okay, so this then means that when he's done this, and if the data says, well, what you said, 10 point something degrees per hour?
11.5, if my mind's
Okay,
correct.
so if the rotation then is say 11 degrees per hour and it's repeatable, that then means that Spurskimo will accept that we're spinning.
Yeah, as long as you show me a spinning ball, I'll accept that.
That is not an answer.
That is not an answer. This has nothing to do with the spinning
Does
ball.
that show a spinning ball?
Are we saying the same thing? I don't know if we're saying the same thing. Are you
No,
going to
Does that show a spinning ball? Does his experiment show a spinning ball?
Because I thought we were going to show me a spinning ball. That's what.
Does
No,
his
he's talking about
experiment show a spinning ball?
just Hector's experiment for now. We're not talking about the balloon, just the pendulum.
Yes. So Hector's experiment will, if it falls within about 11, like plus, I don't know what his margin of error is, but say 11 degrees.
Yeah, you
if
can
it
show me data. Look, yeah, I've told you I accept the data of the model. That's not a problem.
Okay,
we're not asking you to accept the data. We are asking about whether you're going to accept the conclusion that results from that data.
Based off the data, yes.
Yes, of course. It would agree.
Thanks. That's all that we were trying to get out.
Okay, so that now, okay, for the record, this now means that if you get within margin of error, Hector, Spurs has now publicly stated, right, without ability to retract it, saying that if you get within margin of error, it's evidence for the spin.
Okay, now, as we're talking about for the record, do you want to define the margin of error that you're ready to accept?
No, that's entirely up to you. It doesn't matter.
No,
my God.
Okay, if it's entirely up to him, then he can just say whatever, and whatever result he gets, it will.
No.
Yeah.
It will
That's
get correct.
actually important. You have to decide before your experiment what's the condition under which you're going to say, okay, I was right, and what's the condition under which you say, okay, it seems I was wrong. Shall we say, as I'm expecting,
now
11.5 degrees?
Because now,
are you ready to say that if I'm within 3 degrees of that, then you're going to accept it, and if I miss that mark, then you're going to reject it? Is that a fair statement?
yeah, you could say that.
Okay, great.
He doesn't
Now we set
understand
our
what you're
margin of
asking.
error of 3% off, of 3 degrees off. I think that's something I can really work with. Thanks a lot. I think we've settled that.
Hey, Geo, do us a favor. Please do not delete this fucking Hangout.
I never deleted anything out there. All standing on the channel.
Okay.
Oh, Hector, could you
No
do
matter what of a clusterfuck they are.
Keep this Hangout, absolutely. We don't want to delete the evidence. So, like we said,
the time, Geo, the timestamp is like 1:55 to 2 hours or something. Just for the record, if you want to write that down, this is where this happens.
Yeah, but in case we really have to get down to that again, I think we can just go through the video. But yeah, did somebody have a question for me? Because I heard my same.
Yes, I would like. Could you do me a favor?
Yeah.
I'm not very familiar with how. I understand the physics, but I don't know the exact mechanics of it. Could you please write me an equation where the input is latitude and the output is expected degrees in a Foucault's pendulum per hour?
Yeah.
Is that possible?
Circular frequency equals sin alpha omega 0 equals alpha mile times degrees per hour. So the sine of alpha multiplied with 15 degrees per hour.
Okay, thanks.
Yep.
And I guess alpha is latitude.
Exactly. So for 0 at the equator, you get a 0. For 90 at the North Pole, you get the 15 degrees per hour, the 360 degrees in 24 hours. And the rotation is going to be clockwise and counterclockwise on the southern hemisphere. Incidentally, if you use negative angles if you use a negative alpha to indicate the southern hemisphere, so degrees below 0, you're also going to get the negative result. All right. Any more questions that you'd like me to answer? Do you have any question about how you calculate statistical errors? For example.
I don't think so.
All right. With that said, I yield my remaining debate time, or whatever I need to say that you can go on talking again.
So, Spurs, you said that you have taken a look at my experiment. Do you want to talk about that?
Yeah, you can go ahead, absolutely.
All right. So just give me a second. I need to find the file.
Yeah, I'll just deactivate my camera again. I think we're done with that part of it.
All right. I have it here. Give me a second.
Now, that being said, all that I just showed is discretion, because if something turns out to not work at all, I of course have to change it. So, yeah. Again, I'm gonna put all of that in your report. But yeah.
All right. So what I'm planning is I have the stratosphere balloon, as I said, and basically we will have a long bar, one long.
You're still sharing, Hector. Just saying.
I'm still. Oh, sorry. Okay. Can you see it now?
Mm-hmm.
All right. So we have a construction with this long horizontal bar, and on the end, which is here in marked in red, we will have transparent rulers. That's more or less it. The cameras in the middle will look where, as seen from the cameras, the horizon will be. and that is dependent on the altitude of the balloon over the surface of the planet. And that's more or less it.
So you've got cameras to both sides.
What?
So you've got cameras to both sides. Are you going to...
I have two cameras going to the two different sides. The thing is, first of all, it's completely irrelevant what kind of lens is on the cameras, because all that matters is the relative position of the rulers to the cameras. And the second one is that this experiment also is working when the bar is not completely horizontal. So it can swing around a little, but it will still yield valid results all the time.
Because in that case, the horizontal is going to be higher at one side and lower at the other side.
Yes, by the same amount. That's it.
Basically the same principle that I used by using two rulers, one at the one end and one at the other end.
Right.
Do you have a method implemented to synchronize both cameras so that both video feeds are perfectly in sync?
Yes, I have a flickering LED that blinks once every 30 seconds. I think that's good enough.
Okay, that's going to fit. You're probably going to need a video editing software to put both next to each other and probably speed it up or down just tiny little bit to get the cameras to sync, but that's a good idea. Great.
Yeah, that's something I'm going to do. First of all, before I'll start any gathering of the individual frames, I'll upload the videos unedited completely. Because I want actually to give all the flat earthers the chance to take a look at the unedited videos. I don't want any doubts that I edited them in any way.
Yeah.
And then afterwards I'll gather the results. Spurs, do you have any questions?
I'm listening.
Any questions?
Not from my side.
The thing is, this experiment is rather simple to build, and the hardest thing indeed is the bureaucracy to get this approved.
Yeah.
Yeah, probably.
The explosion, it's not an explosion, the maximum height of the balloon where it's going to pop is about 36 kilometers. And you can really start seeing the curvature about 8 kilometers in altitude.
Fuck the government. Just launch the damn thing. Better to or easier to ask for forgiveness than permission, right?
Do you think what
Germany.
happens? Do you think? What do you think happens when a German aircraft thingy enters Poland airspace without any warning?
Hey, you guys have a good relationship as neighbors, don't you?
They're still a little suspicious.
Halsoy, Germany is not Denmark.
Like,
well,
what?
I think we could all agree on that.
Not yet. Not yet.
We're anyway got to call out a European nation in a few years to come.
Don't worry, Halsoy. Denmark is just Germany's Canada.
Hey,
Yeah,
now,
that is a surprisingly accurate description.
It actually is, but just you wait. You're up. The Kalmar Union will rise again, and we will conquer all.
You realize that will mean that Denmark is in charge.
Kalmar is a nice city, by the way.
See, this time around we have the money, right?
Yeah.
Fucking oil.
One thing regarding the balloon, Alex, it might be worth considering adding 1 centimeter tall stripes of duct tape to your ruler just to make sure that you can see the scale from your camera. So you've got 1 centimeter.
Yeah. That is planned. I mean that the rulers will be modified to be
so that you can see it clearly with the camera, and also if
conditions.
there's fog involved or
Yeah, we should do that. I mean, we're obviously launching it on a date where there are no clouds and no fog and no rain. Anything.
They also might want to put in frame a bubble level.
Frame a what?
Put in frame of the camera a small bubble level.
The construction plans that are in this document are rather old. The new construction looks a bit different to accommodate for the demands that the authority were giving. So The principle is the same, but the geometry that I've drawn there. For example, the horizontal bar is now only 1 meter long and not 2. But
You're not going to be going to Globus for your fucking construction stuff, are you?
what? I'm not going to.
You're not going to be going to Globus for your construction project?
No.
Never mind. You don't get the joke.
Apparently.
Globus. You remember the Globus store in Germany where they used to before Walmart?
Ah, yeah, right.
Yeah, never mind. You lost it.
All right. So, any questions regarding the experiment from anyone?
No, just good luck. Make sure you give us what we're asking for. So
Yeah.
Will that experiment show a curve?
It should.
it should.
There's one thing, due to atmospheric lensing, it might show less of a curve than we're expecting.
Yeah, but we're expecting about 15 degrees or so at 36 kilometers.
Okay.
That's longer than the rulers that I have. So it will literally be out of scale after a certain height.
Yeah, but we can extend the scale further in our image, but yeah, that shouldn't be really that big of a problem. Yeah, and the maximum angle change that you can expect in the atmosphere, basically from vacuum to full atmosphere, is 2 degrees, and we're probably going to be at significantly below that because we're going to get rid of 75% of atmospheric pressure at 11 kilometers. So I don't think we're going to get more than 1 degree of distortion due to atmospheric lensing.
Spurs, you understand that this experiment is it's irrelevant which kind of camera I use. Do you understand that?
Yeah. Scroll up a little bit so you can see.
Well, yeah. Do what you got to do. Do whatever you got to do.
Yeah. No. I wanted to confirm it. Do you understand that the sort of camera, the sort of lens that I'm using is irrelevant for the experiment?
Look, Gio, you know what the stakes are.
That's yes or no.
Gio, the stakes.
That's a yes or no.
That is the stakes are high. You know what's required. Do whatever you need to do.
Yes, but please answer my question, because I don't want you to bitch about the fisheye effect of the lens afterwards.
You know what arena you're in, so do what you need to do.
Answer the question, Spurs.
We're going to measure the angle by aligning the image with the ruler.
Experiment how these fit. I will explain.
Spurs, we've been over this at least 3 times already in this hangout alone about this. The reason they're asking is you need to have a solid position so they can actually see if you can confirm or deny the results. If you have no position on the matter, there's nothing stopping you to just back out of it, no matter what the result is.
No, of course not.
So yes
That's
or no?
also the standard.
Stop, Hector. Wait. I want my answer now. Is it a yes or a no?
To what?
That the lens that I'm using for the experiment is irrelevant towards the results.
That is your choice.
That was a question.
That is not.
You are not answering my question.
It doesn't matter to me what you use.
I understand that it doesn't matter to you, but do you understand that the premise of this?
It's up to you. You can use,
Spurs, you're not listening to the question.
I know that I can use it, but do you accept that it's valid to use a fisheye lens? That's my question. Do you accept that the results of the experiment are not dependent on the lens?
Well, again, like I said, the results will tell us what you're claiming.
No, you're not listening to the question.
Won't tell us.
You're making a claim right now that it makes no difference. So
no, you're asking a question.
Yes, I'm making a claim and I'm showing it on the screen. Look, wait, stop, full stop.
Okay.
Look at this drawing. The circle with the angles here. Do you see it?
What?
Guys, I'm going to take a break for a few minutes.
So you see it. Okay. See the angle delta. The delta is the angle that I'm trying to measure for the experiment.
Mm-hmm.
That is the important one.
Okay.
And basically, the red line above delta is the eye level. And the green line is the direction in which the horizon is. So the angle delta describes the difference between the horizon being at eye level and the horizon being below eye level.
Okay.
Okay. So the method that I'm using to measure this is by aligning the eye level with the camera and measuring the angle between the eye level and the horizon directly by looking directly through a ruler from which I can derive the angle via the tangent law. All right. That means that how big or how small the field of view of the camera is not important towards the result of the experiment. Do you agree?
No, I agree. That's your claim.
I've explained it to you.
You've given me an explanation. Now you need to prove it.
I've proven it by mathematics.
Well, again, that is in your head. You've written it down. Now put it
Holy
in.
fucking shit.
No, it's geometry. You're denying geometry at this point if you don't agree with this.
No, I agree, and I've said we would test the claims. We'll verify what he's saying.
No.
So you agree that this method is valid for measuring the drop in the horizon? Is it valid?
That's the question.
You can
Is this a valid measure? Is this a valid experiment? Is this something you will accept as evidence for a drop in curvature? That is the question that you will not answer for whatever reason.
The reason why I won't answer it, because if you're telling me how to do the experiment,
I told you.
Do you see it as a valid experiment? That's not. You're not answering the question. Do you see it as valid?
Because the answer is not valid. Whether I agree with it or not, the
Yes,
answer
it is.
it's not valid. No, it's not.
Yes, it
Because
is.
the results are valid. That's what is
The
valid.
method valid.
That's not how this works.
You're
How
doing
you
it
win the
backwards.
race is not important.
But
Did
you know
win
why
the
he's
race?
doing this?
That's
He's
what
doing
I'm
this
saying.
so he
I
can
will
say that.
observe your results. I will verify what.
He wants a way to back out no matter what the result is, and that's why
Yes,
he refuses
yeah.
to answer these things. And this is what he's done in the past, and that's why I'm being so pushing this
What's
point.
to back
and
out
did
of?
it
If you
the
can
last
prove
experiment too.
rotation, if you can prove curvature, there's nothing to back out of.
No,
Yes,
How do you
Spurs-
go about?
Wait,
Spurs?
stop. Because what I'm predicting, if you don't understand this, is when I show the footage of the balloon cameras, you will say it doesn't count because it's a fisheye lens, without thinking about why the lens itself is not important. That's my prediction.
Criteria.
Yes.
Give us the results, and then we can discuss it afterwards. No point.
No.
Do you understand why they don't want to do that?
Well, then don't do that. Then.
No.
Do you understand
Spurs.
why they don't?
Then do it the correct way, whatever way you think is the correct
You're
way.
trying to do the correct
God.
way, but that
You're
involves
failing
you
at logic.
confirming.
Spurs. Completely
He doesn't
failing
even
at logic.
understand that question.
How can I tell you how to do your method?
That's not what we. What
You're
we
not
asked.
telling them
not the
how to
problem.
do it.
I'm proposing the method now. I want you to confirm that my method is valid.
Yeah.
It's
The
valid,
question.
It's as valid as any other way of trying to get to the answer.
No, it's not. No, it's not.
No, it's not.
If that was the case, we would. If that was the case, I would be able to go in my kitchen, pour water into a pot, and have the cure for cancer.
That's the wrong answer there.
Well, he's correct there. That's not the cure for cancer.
Yeah,
Exactly. So that's the
But
wrong
you just
answer.
said- but you just-
answer. If you pour hot water and find the cure for cancer, who cares about the hot water? You found the cure for cancer.
No, Spurs. So before you start to move on to a different topic, because
There you
you
go.
can't
Thank
stand
you
on
very
the same, you can't
doesn't matter about
stay
the
on the same
method.
thing.
Give me the
Right.
answer, and we
So-
will look at the answer.
So Spurs, again, the reason why this is being harped on is the fact that if you right now agree that this is a valid method, okay?
Yeah.
Let's just hypothetically right now say that you agree that this is a valid method.
Mhm.
That then means that we can talk about the result in an objective manner. Because if you don't agree, or the same thing, if you disagree with this, then he can find another way that you can agree is a valid method, or he can go in detail explaining why this would be a valid method.
Mhm.
One of those two, okay? So the reason why is because when the data comes back, for you to be able to discuss it in an objective manner, you need to be able to have be able to understand how you would go about confirming or falsifying the results.
Yeah, that's after he's given the answer. What? I want
No,
No, that's
No.
beforehand.
that's beforehand. You need to be. Hang on, Spurs. So
Well,
it's
again, you're telling flat earthers to be well, again, flat earth.
Spurs,
You have.
Spurs,
You're asking
it's very
why-
clear to everyone that, like,
I've asked you what-
it's previously in this hangout when you said that we test stuff. It's very clear to everyone that you have never in your life done an experiment.
Just deliver what we're
Because
asking for.
to do an experiment and actually
Can
go
you
about
deliver?
falsifying the results, you
Can
need
you
to
deliver?
know what the expected outcome is based on the method you're using and which conclusions you're starting with, or what conclusions you can draw from your starting points and the methodology you're using. If you can't agree on that before doing the experiment, you have no way of verifying or falsifying the results after the fact. That's what people are trying to push you on.
Can you deliver your claims?
Oh, for fuck's sake.
Most of them, yes.
Right.
But again, before
That's all any flat earther interested. We're not interested in your gobbledygook.
Spurs,
We're not interested
This
in
isn't
your
gobbledygook.
blah
This
blah
is
blah.
the basic part of the scientific
We're
method, you
interested
fucking
in the
idiot.
results, so we can test the results. What you guys find. If you can deliver a spinning ball
again,
and curvature,
Spurs.
we will test and
Spurs.
verify what you have found.
Can this show
Spurs?
curvature? Does this show curvature? What's on
Yeah.
screen now? It's a cartoon, but
when
if we
you-
replace this with a real image, does that show curvature?
When you say analyze the results, Spurs, you need to know what you're analyzing first. And to know what you're analyzing, you need to know whether or not the methodology is correct.
There's geometry here. He's using geometry to validate his method. Do
Whatever
you see why he's doing that?
Fine. Any method you like, use it.
So
Just-
answer me.
that's-
So answer, is geometry a valid method for determining if your experiment is valid?
If that's your expertise, use it. If you
That
can
was not
prove
an answer. Again,
That's,
Yes,
it's
That's not an answer.
it's valid,
always
it's
nonsense.
valid, it's valid. If
It's
you
always
can-
nonsense.
Yeah, it's
First, say
valid.
one rational thing, please.
It's
please,
valid
one
if you
rational
can
thing.
deliver.
Spurs, why are you being so obtuse on this? Just answer the goddamn question. It's simple.
Is it a valid experiment?
Yes, if it proves a result.
but
No, it doesn't matter if it
Wait,
proves a
stop,
result.
stop. Let's generalize this. Spur, do you think that there are methods involving geometry that can be used to determine curvature or to prove curvature?
This is what we're trying to find out, Gio.
Yeah.
Can it? We're trying to find it out right now.
That's the question
Is a
that Alex
sphere a
was
shape?
asking you.
And I don't know. That's why you're doing the experiment.
No, he's not
It's a
asking
sphere
about the
shape.
actual. He's not asking about the Earth's geometry. He's asking about any geometry. Is it possible?
Basically, can you use the laws of geometry to check whether the Earth is curved or not?
Yes, if it's possible, if you know what you're doing, absolutely. If you can show that, we'll accept that.
If you know what you're doing. Okay. Does this
Absolutely.
guy appear to know what he's doing?
We don't know until he comes with the results. Like you failed.
No, you could determine that already if you know what you're talking about.
Oh my
He hasn't given the answer.
You could tell already if his method was valid,
You want me
if
to
you
predict
understood what he was doing.
fortune? I haven't got a crystal
You
ball.
can tell his method is valid because of the geometry he's using.
Are you asking me or telling me?
I'm answering the question for you,
Well, there you
which you
go.
refuse to answer.
You speak
The
for-
method is valid because the geometry supports the experiment.
If you say so, just bring us the results.
Not if I say so, it is a fact.
That's your claim. Bring me the
Spur.
results.
It is a fact.
Spur.
Guys,
Can I, here,
let me-
let me try this for a
Spur.
second.
may I try to explain to Spur how exactly the thing with the rulers works and why that means that the camera lens doesn't impact
No,
the experiment?
I don't think it'll help.
None of this needs to be explained.
It won't help, but please do.
If it works and you can bring the results, there is not an issue.
Basically, what the rulers are going to mean is that these will give us a scale. So if we know the arm is 1 meter long and on the ruler the horizon is 2 centimeters down, then we can calculate an angle from that by basically reading the angle of the ruler, of the ruler. This way, we don't have to worry about any distortions in our camera, because the distortion would equally distort both the horizon and the ruler, and the number on the ruler would still be at the same position over the horizon. This way, any distortion caused by the camera we were using or the lens that we're using would be cancelled out. Does that make sense to you?
Yeah, that makes perfect sense.
All right.
All right. Then I think
thanks.
then now you can answer my question. Do you agree that the lens?
Alex, you basically just agreed to it.
Yeah. Okay.
saying that-
But I wanted confirmed. I wanted.
Yeah, I agree
Second
to any
completely.
method that you want to try. If you want to use geometry, if you want to use fisheye lens, that's entirely up to you.
So you agree that when I use a fisheye lens, my results will be valid?
I don't know that though, do I?
Oh,
Hector has
God.
just explained it to you, and you agreed.
How can I know the results, your findings, unless you give them to me?
Geometry.
We're not asking about the results. We're asking to establish basically the standard of
premise of
how
the
we
experiment.
come to those results. Because if
The
there's
testing parameters.
Yeah, use whatever testing parameters you need to prove the shape of the Earth. Do what you have to.
It's like a child, I swear.
It's like beating off a dead horse. Wait.
God.
Well, see, even that would be more productive.
I already regret coming back early. I'm gonna be away for a few minutes.
Okay, let me try something. Spurs, the reason why they're talking about the methodology now and not after the fact and not after there are results is because they don't want, because if you or someone else has a problem with has a problem with the methodology after the fact, they don't want to have to go through the whole process again of launching it again and doing the whole thing again just to fix the methodology. That's why they're asking now.
Yeah, but hold on. That's your choice, isn't it?
No.
What?
No.
That's-
Clarify?
If every
No.
flat earther is asking for proof of spin, proof of curvature, and you choose to go through this method, that's your choice.
Yeah.
No, see,
Yeah, because it's an easy and awesome way to prove curvature directly.
Well, then go for it.
as dumb as I think he is, I don't think he's dumb enough to not understand the question. I think he's just purposely avoiding it.
He's purposely doing this, I'm sure.
I can't tell, to be honest.
So
I'm almost certain.
it's a method so that
Look,
he
at the end of the day,
he
Hector,
cannot be
you're-
pinned
because
down on
you're in a
taking a
situation
solid
He
where
will
standpoint
not.
on
flat.
something.
That's
No, he
why
never
you're
will.
Because if he does,
here trying to prove
if he
shape
goes
of the
on
Earth.
one side of
You
it,
think you have the
he
answer.
can be wrong.
Go
But
ahead.
if he refuses to take part of it,
Nobody's
he always
If
has
you
the option
service
to
what
back out.
you do.
Here's the
Whatever
answer,
method-
Spurs. Here's the answer. Can you measure shit? Can you take a ruler up to something and measure it?
Absolutely, yeah.
Okay, can you measure angles?
Can you measure a triangle?
Yeah, well, yes, of course.
So you can measure the height of a triangle and the length of a triangle.
Okay, what's your point?
And then you can know the angle based on those two numbers, right?
What's your point?
Answer the question,
point
Spurs.
is,
Jesus
that is the
fucking
basis
Christ.
of this experiment. That's the
No,
point.
I don't want to dwell on this. What's the point?
That's the basis of this experiment. That's the point. Do you understand
fine.
that?
That's fine. I'm not arguing with you.
So
That's
if you
fine.
know the height and the distance, you know the angle down to the point of the horizon.
Why are you
Okay?
trying to get an argument out of me? That's
Do you
fine.
understand
okay.
that?
I
Do you
agree.
understand that? You
Absolutely.
agree. That's valid. You can use
Absolutely.
those things to get an angle, and you can measure an angle. So you can measure the angle down to the horizon from horizontal. Are you agreeing with that?
I
Can
do.
you agree to that?
I do.
That little red line there, the
Mhm.
horizon, that is a measurement. That is the H in that triangle. That
All right.
290 m bar is
All right.
that I 100 centimeters. That is the
Absolutely.
blue line, okay?
Mhm.
The delta measurement is the
Okay.
tangent inversed height over the length, which is the simple inverse tangent equation to get back the angle from those two measurements. This is
Okay,
simple
good,
trick.
good.
Simple trick, right? You could go out and validate that angle is what you get back. You can go out with a protractor and you can measure it.
It's very
Okay.
interesting. I hope it,
Geometry. No, the point is geometry is valid and it's usable in our experiments, and we can use geometry as a basis for giving valid experiments. Do you accept that?
Absolutely.
Is this experiment valid in its methodology?
All experiments are valid.
No.
No.
Not
No.
at all. If
That's
he used
exactly my-
false, if he used inaccurate geometry, it would not be a valid. It would not be a valid experiment. If this was
There's your answer
invalid
then.
geometry, if
There's
he
your
was
answer then.
incorrect transformations and incorrect assumptions, it would not be a valid experiment. Okay.
Absolutely, yeah, of
Using
course.
things. He has to be using things that are validated and
If somebody
measurable in
goes to use
reality.
the method, they would
in
be
order to
wrong,
do
right?
this. So is
They'd
this
be
a
wrong.
valid experiment? I don't care.
If it's done
It's a
correctly.
yes or no question. Is
Yes.
this a valid? It is a valid experiment for measuring the drop in the horizon based on elevation.
Yes, if that's what you want to use. Yes, absolutely.
Not if it's what I want to use. Is it? Is it a fact that this is a valid experiment for measuring the drop in the horizon? A fact.
Is that a claim? Are you asking me? Or is that
No, is it a
No.
fact that this is a valid experiment that you can
We're
use
asking if you
using
agree with
geometry?
that.
Is it a fact? It is a fact. I'm guaranteeing. Just say yes because that's the answer.
Not until
This is a fact.
Not until you prove it. Not until you give an answer.
No.
Go measure a
That's not how it
triangle.
works,
That is
Spurs.
proof. That is you going and proving
Well-
it. Go measure a triangle, give it a defined height, give it a defined length, and
Mhm.
measure it. That is proving it. Is this a
Of course,
valid
yeah, so
experiment?
if you know the height, length of something, of course, we
Is this a
agree.
valid experiment?
Absolutely.
So this is a valid experiment and will tell us the drop on the horizon based on elevation.
I hope so. I absolutely hope so.
That's
Jesus
not the
fucking
answer.
Christ.
That's not an answer.
It is or it isn't. Yes or no.
Yes, it's a valid experiment.
Yes.
If
Thank
Yay,
you
there we
for
go.
only
Yay.
saying
No.
yes, Spurs.
No.
Thank
He had
you.
an
Yes.
if. He
Yeah,
had an
he had
if
an if.
condition. He had an
It is
if there
yes.
because he
Fuck your if.
still avoids
It is yes,
answering.
Spurs.
all right, Kara. Yes.
It is yes. You can validate the methodology. You can measure the height of a triangle. You can measure the length of a triangle, and you can measure the angle of a triangle. You can validate the methodology for this experiment. Okay? Do you understand that?
Yes.
Going higher up is just a bit of more geometry. By using that assumption to determine the drop in the horizon based on a sphere, if you scroll up a little bit where you show that,
You ever thought about doing TED Talks?
Oh, here.
So
these are just
instead of
triangles.
shifting,
It's
instead
still
of shifting the
triangles.
topic again, stay on it, Spurs.
Okay. No, I agree. Look, do what you need to do to prove what we're asking.
As you get higher above a sphere, the horizon will drop by a predictable
I've said yes
angle,
about 1,000
by a
times.
predictable angle based on the relative radius
I say
of the
yes.
sphere.
That's
That is
obvious.
geometry, and you can make a circle this whatever diameter scale you need,
I said
and you can do
yes.
this at whatever angle. You can do this yourself and validate the mathematics here that he's using. You could type all this into
Why don't
a
you
decent
wait until after
calculator
you get
and
to them?
see that it returns the correct numbers. You could validate his mathematics that he's using. Everything here you could validate to show that it is a valid experiment. He's given you all that and provided you enough information for you to say this is a valid experiment that does show the drop in the horizon. So please just say yes, because as soon as you do, that's the point where you can't turn around.
Deflection in 3, 2, 1.
Let's talk about. Seriously, it's your method.
No,
Yes, it's your method.
geometry. This
Okay.
is
No,
this
it's
is everybody's
Oh my
method.
God.
This is
Okay.
the only method you have.
If that's your claim, Cara, how many times
This
have
is the only method you have. It's not my claim. Prove me wrong.
That's what we're going to do when you give us the answer.
No, it's
No.
because what you'll do is say, well, no, the test was invalid and it doesn't work after the fact.
Yes.
That's the game you'll play.
This is the point.
It's not a game.
Spurs
right,
again.
right,
Spurs.
game.
Spurs.
Do whatever you
It's your
Spurs.
game.
a spinning
Spurs.
ball.
Spurs. You need to either agree or disagree on the methodology before the experiment to be able to weigh in on the experiment.
That's not what happens.
Spurs, for example, if Geo came up and said he's going to have an experiment where he's going to measure the surface of the Earth, and he's going to say, well, I'm going to use my camera, but I'm going to point it up at the stars on a balloon, we're going to say, no, that's not the right methodology.
No, I'm not.
See how-
I'm going to say, do whatever you have to do. If you think that's the right
Doesn't work like that, Spurs.
Doesn't work.
It doesn't work like that. Again, Either this is a correct methodology to prove it, or it's not. If it is, and you agree, you have now written something in stone. So if the data shows a curve, you have to accept it.
That's my point. You're trying to tell me how to do his job. I'm not going to.
No,
we're not.
We're not.
I'm asking if you're going to accept the job that he does.
Yeah, exactly.
Yeah, they're asking you if you're willing to accept the data once the experiment is in.
Well,
Okay, accept the conclusion based off of the data, I guess would be
Yes,
the correct
yes,
phrasing. Yes.
The data of the model, yes?
No,
What
the
is
data
data of the model?
experiment.
Fuck that. The data.
No, the model you can do the
data of the model, right?
no Spurs.
No,
You
it's
can
just
do
data.
this.
What you measure.
You can do
data.
this wholly independent of any model. All this would show, like at its bare minimum, all this would show is that the horizon doesn't follow eye level.
Yeah, if you can show that, if you can show curvature, that's all we're asking for.
No, again, the question is
how so? Stop. Listen,
No,
just listen.
Does it show that?
It's
Does
in a
it show?
nutshell, isn't it? It's in a nutshell. What we're asking for. You've heard Poncho, you've heard Vinny, you've heard Antonio.
Who cares? Who cares? Who cares?
Show us
That's
proof.
that's not the issue we're having.
Spurs, that's not the issue. The issue isn't that what people want to see. The issue right now is, do you agree or disagree that this experiment would show that?
Well, right now, there is, for me, there hasn't been any experiment that shows curvature.
You're not answering the question.
Not answering the question.
It's a hypothetical, you idiot.
So therefore, I can't say what would and
Yes,
wouldn't work.
Spurs. Again,
How can I say? I can't say.
Spurs. His claim, and you can check this with the geometry. You can put an ice pick or like one of those wooden sticks on an icicle and tape it in front of your camera lens on your phone and see if this is correct. What he's claiming is, if he has a level stick in the center of the frame, and then you have a ruler at the end so you can see if it drops down, is that a valid method of determining whether or not is that a valid method? Listen. Is that a valid method of determining whether or not the horizon drops? And again,
yes or no question. Yes or no. Yes or no. Yes or no, Spurs. Yes or no.
It is a yes or no question. There are no other answers.
No. Yes or no.
To what?
Say it again.
Okay.
To a practical test. Yes, I accept a practical test. Absolutely.
He always
I'm willing to
changes the
accept that
terms.
answer.
You always change the freaking terms.
do
What are
you
you
want to
agreed
know what the
something-
really
you
funny
agreed to
thing is?
something else.
Yeah.
You agreed to something else.
Do
Yes.
you know what the really funny thing is? I discussed this already with Riley, and he accepted after 2 minutes.
Yeah,
Because even he understood it.
But that's because I don't think Riley is willfully dishonest like Spurs is. I just think Riley is misinformed.
If Anthony accepts it, then he will, when he gets the answer, then he will have to explain his finding.
No.
The geometry
No.
is
Let
for
me
measuring the
Spur,
universe.
let me explain. He accepted that the results I'm getting are valid whether I use Fisher lenses or not.
True.
Right. So the question is, will that show to him that the Earth has curvature and it's spinning?
No.
That's a different question.
Yeah, that's a
Well, then I
different
don't-
question.
No, that's not
The
what I. That's a
results
different-
of the experiment and validity of the experiment are two different things.
Yeah, we're asking for the validity of the experiment, not the result, because the result isn't in yet. Which you clearly
Look.
have a hard time / not willing to.
I'm not telling a guy how to
Accept.
do his job.
That's not what
Oh,
we're
God.
asking for.
Okay,
Is it valid?
let me
Is it
give you.
valid?
Yes, you said
You're not telling him to do anything. You're just saying if it's valid or not.
So let me propose a
Proof
hypothetical for Spurs that he might
That's
actually
what
be
we
able to understand. So Spurs, you have a camera on your phone, right?
Mhm.
Okay, good. And I was kind of confused. Like, do you want to argue about that too? That answer too. So you have a camera on your phone. Now, let's play a hypothetical here. Now, let's say you're in your living room or whatever room where you have a tabletop. Okay.
Mhm.
On your phone, right next to the camera lens, in the middle of the camera lens, so that if you open the camera app, it would be in the center of the frame. You tape on a wooden stick from an from like an ice cream thing, one of those wooden sticks that they use for model building and whatever. Or it could even be a matchstick, right?
Popsicle stick.
Popsicle stick, yes, right. And at the end of that, right, you probably, at least at one point in your life, you owned a transparent plastic ruler with millimeter notches on it, or like markings.
I know. Yeah, I know what they are. Yeah.
Right. Now you tape that on the end of the popsicle stick. Okay, so you now have a popsicle stick taped next to the camera lens on your phone with a ruler at the end of the popsicle stick.
Mhm.
Now, standing next to a tabletop, so that let's say the 0 millimeter marker is like right on the edge of the tabletop, and let's say you're sitting on your knees. Now, if you were to stand up, not moving the phone in any direction, just holding it straight out on your arms and moving your arms with the rest of your body as you're standing up, the tabletop would now go down on the ruler while you're filming it, correct? Because you're elevating.
Yeah, maybe not. I should claim. I'll have to test it.
Maybe not. Like, test it.
Okay.
I
Yeah.
don't accept anything that
Idiot.
Scientology, pseudoscience brings to the
What
table
the fuck are you talking about?
Scientology.
Until I verify what you're saying. It's all
All hail
claim.
galactic overlords.
Verify what you're saying.
Are you
I worry about
blind?
my feet and
Are
levels.
you actually a blind person? Are you a blind person, Spurs? I actually need to know that.
If you
My feetins are triggered.
Are you blind, Spurs? Are you blind?
The same thing. You could explain this to any flat earther.
He is blind. I swear he is.
Any of them would ask
You're a blind person.
requirements.
Well, Spurs, you don't speak for every flat earther, so shut up.
Yeah, but we're all in the same boat.
No, you're not.
No.
I don't know how to make it more simple of an experiment than that.
I mean,
If you stand up, if you're sitting down and then stand up, do things in your vision move down?
Depends if I'm looking where I'm looking.
Okay, if you're sitting down, looking straight ahead, and stand up, do things move down?
No, things stay where they are.
In your vision.
You look in the same direction. You don't change the angle of your head. You look in the same freaking direction, Spurs. What happens?
Up. Use your head.
Notice how on any given point he refused to take a position because he needs to be able to back out of it.
Yep.
Spurs, is the sky blue?
It looks that way.
Wow, he actually took a position.
It looks that way. So what is it then?
At night,
Is it actually blue?
In England, it looks grey.
Oh, for God's sakes.
Why is the sky blue, Spurs?
I have no idea. Why is the sky? Well,
Common scattering and the lack
Really
of
scattering.
optical sensors that detect color violet in our eyes.
You can prove it with a polarizer, believe it or not.
look, these are just claims, Cara. And again, stop.
They're not just claims.
You can actually prove it.
They're not just claims.
I like how you guys make claims. That's what I said. There are no theories.
They're not just claims.
On a flat Earth.
They're not just
Triangles are
claims.
measurable. Is that a
You don't know
claim?
what theory is.
Is that only a claim?
There
A
is
triangle
no.
is measurable. A triangle is
There's
measurable.
no
Is that only a claim? Chris?
You're either
Is
in
that
or
only
you're out.
a triangle is measurable? Is that a claim?
No, of course not.
Then
Because I've
nothing
tested-
we've said here is a claim.
It's a claim to. It's a claim to those who haven't tested it,
What the fuck?
haven't verified it themselves.
So can you measure a triangle?
How many times are you going to ask me the same question?
It's the most
Come on.
valid question that you can't seem to understand why I'm asking you, because it is extremely valid. If you don't understand that you can measure a triangle, because that's the whole basis of, is this experiment valid? If you can't measure a triangle, then I'm sorry.
You're
It's like, what
talking.
the hell?
You're going from the simple to the wild in like one sentence. Come
No,
on.
I'm not. I'm applying geometry to
Going from the word
reality.
measure to the word triangle.
Can you do this? No, for
Illuminati
the sentence.
program.
Can you
One
measure? Can you measure
Yeah,
space around you? Can you measure the Earth? Because it's the same thing as measuring triangles.
I've measured my penis and it's 2 millimeter long. Measurement works.
Yeah,
Can
measurements
you measure a
work
triangle?
as long as you verify what you are claiming.
Can you measure a
He
triangle with a
verified it by
camera?
measuring it.
Can
No,
you
you
measure a
guys don't like
triangle? Can you measure a triangle with a camera and a ruler?
Like if you said to me how tall you are, Kara,
Can you
That would
measure
be
a
just-
triangle
I
with
would
a
have to
camera and a
verify.
ruler?
I would have to verify
Can you
all of
measure a
your.
triangle with a camera and a ruler? And knowing how far the ruler is away, I guess.
If you know what you're doing, of course, you can do anything.
No.
No.
If
No.
if that's true, then my cancer example would work, because if I know what I'm doing, I can do anything, and I know what I'm doing. I'm putting water into a pot.
And curing cancer.
What?
Yeah.
What do you mean?
Spurs, it's like you fucking saying you can't put shoes on because you didn't
Yeah.
make the shoes, or
That's how stupid your argument is.
Yeah.
I said you can do anything if you know what you're doing.
Yeah, and I just and as I said, by that logic, I can cure cancer by putting water
Totally
into a
irrelevant
pot.
though, because you're still dodging the question. Can you measure a triangle with a ruler and a camera?
Yes.
And just knowing the distances.
Yes.
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 Is that a yes?
That is a yes.
Yes, you can do that. That is possible. Is it
Anything-
accurate?
Anything is possible, Kara.
Does it represent reality
No.
and the actual angle there?
We got to verify that, Kara.
Does it measure? Does it comport with reality when you do that?
This is why I wanted to teach you in your room. You didn't. You didn't
No,
allow
this
you
is
ran
what
away
you don't
after
understand.
5 minutes. You
you're
wouldn't allow
not
me
a
to
teacher, Spurs, so don't worry about that.
Other questions, Kara.
If
Or
you can
one after
measure a
the other.
triangle with a camera and a ruler, you can know the angle
You're jumping
to any
from
point.
A
You can know the angle to any
G
point. You can know the
to,
angle
you
to
know,
any point on that ruler. Right?
So,
Right?
yeah, everything's possible, Kara. Everything.
Not everything is
No,
possible.
not everything.
If you know how to do it.
Everything is possible, then
Not
I.
if no, you know how to do it. Not anything is possible. You can't make the Earth flat if you want it to be.
I can't breathe water if I wanted to.
If you know how to do it, you can.
Breathe
No,
water.
you can't.
Please try that.
You go underwater
Yeah.
and inhale.
Please, please do the world a favor and breathe water.
Yeah, go to your bathtub right now, fill it up, and please prove to me that you can breathe underwater.
You know how to do it.
Anything is possible.
You just have to think about
I
it.
don't know how
right
to do
way.
that. But there was a guy who stayed underwater for 22 minutes.
I said
can't do that.
breathe,
Yeah,
not
but
stay under.
breathe
I
it.
said breathe it.
22
I said
minutes.
breathe
How-
it, Spurs. I didn't say stay under it.
I'm pretty sure that guy, if that guy could breathe water, he'd probably still be underwater. He could be underwater indefinitely.
Yeah, maybe
I mean,
it
assuming
would
he
cool
didn't
out or
eat.
something.
If you knew how to do it, then it's possible, right?
Oh my God.
Spurs, he didn't
no.
breathe it. He
No.
stayed under it.
What's your argument?
You said you could do anything.
Yeah, it's if you know how to do it.
So I said you. So you said somebody knows how to breathe underwater. So if they can do it, then you can do it.
It's so stupid. You won't acknowledge that you can measure a triangle with a camera. It's like, what the
I know.
fuck is wrong with you, Spurs?
Yes, Kara.
So you can measure the angle with the camera.
Yes.
Good.
any-
Okay,
measure
good. You
with
said
a
yes.
ruler. You can do that.
Okay,
That's
then
possible.
by extension, you agree that this experiment is valid.
Everything is possible.
Not asking that.
Fuck's sake.
That is not the question.
If
Not
you know.
anything is possible. Is it valid? Is it valid? Yes
Then-
or no? Is it a
That
valid
makes no
experiment?
sense.
Is it
what you're
valid,
saying.
Spurs? Yes or no? Is it a valid experiment? Yes or no? No extension to that. Yes or no? Period.
You want to fight?
No.
Oh my God.
Answer.
We literally just
Yes
want
or
one
no?
answer.
Period. Is it a valid experiment? Can we use geometry to validate this experiment? Period. Yes
If you know what
or
you're doing.
no? No. Yes
know what
or
you're
no? Yes or no? No conditional. Yes or no?
Well, it is a condition. If
Conditional.
you
No,
know
there is
what
no
you're
Yes
doing,
or
conditions.
no?
yes. If
Yes
you don't know
or
what
no?
you're doing,
Yes or no?
on the condition you know what you're doing.
Okay,
Spurs,
so
yes
he
or
knows what he's
no?
doing,
No.
so we're good.
Okay, if
Would
he
you
knows what
accept
he's
it if I
doing,
said that Alex knows what
if he knows what
that
he
Geo knows
perfectly
what
knows
he's
what he's
doing?
doing, and it's valid to all geometry, we can validate the experiment, and he knows what he's doing. Your little stupid conditional, he knows what he's doing. Is it a valid experiment? Yes or no?
If, yes.
Oh, thank God.
Yes. If yes, or just yes. It's just yes or no.
Yes, he knows what he's doing, and
If
that's
he
it,
knows what
Barry.
he's doing and he
He just
demonstrates
said
it
Alex
done,
knows
Let's
that
move
he
on
knows
to
what he's
revolution.
doing.
we're assuming that he knows what he's doing to begin with. That's the premise
Again,
of
that's
this
the
whole thing. We're
problem.
assuming he
Then
knows what he's doing, and everything here is going to be demonstrated as shown.
that's the problem you have.
If he does this experiment, and shows it to be accurate, demonstrates that his rig and everything is accurate, is it a
So the
valid
key word-
experiment? That's the whole basis of everything. That's the whole basis, is the fact that he's doing it correctly. Yeah, that's the basis of everything here. He's doing it correctly. Is it valid?
If he's doing it correctly, yes.
Thank you.
Okay.
For fuck's sake.
What, hour and a half later?
Yeah.
Yeah, more or less, yeah.
Fucking
Yeah,
I'm
those
beginning
fucking
to
synapses be fucking firing away.
This can sometimes be, I think, for all of us.
Okay.
Yeah,
Hey,
I think
actually, Gio, I'd like to ask you a question about your actual experiment, which we have is valid. Are you going to have some kind of pressure or altitude reading that's just readily you can just see just via the camera?
we originally planned to have a altitude meter and a pressure meter. How's it called? But
Barometer and altimeter.
barometer, yeah.
Well,
But
most
unfortunately,
altimeters are just
unfortunately we had to drop both because budget. We are financing this via a non-profit organization. The thing is that the GPS relays that I'm using still have an altimeter built into them, so we can use them.
Okay, that's
But
good.
there's no extra device that is measuring the altitude.
Hmm.
Yeah, this thing would have doubled the budget, so couldn't do it. Most expensive thing
for
of
any
this
given
entire
so for
apparatus.
any given moment during the video or during the test or when you're looking back on it, could you just say, you pause the video and say we're at this altitude?
I think we can, yeah.
Okay, good.
How are you going to synchronize cameras and the GPS sensor?
Simple.
Timestamp.
The GPS sensor has no timestamp, but we'll be running a standardized clock, so we'll start everything simultaneously.
Yeah, that's what I mean.
Yeah, okay, yeah.
Okay.
Cool.
So you think you're going to the South Pole, guys? Yeah.
Wait, what?
Do what now?
What?
You think
Yes.
you're going to
Topic
the South
change.
Yes, I was there in 1992 to 1993, and May 17th of this year, I will be heading back down for another 13 months.
Holy fuck,
You
that's
realize-
awesome.
I want to
there
go
is
to
no-
the South Pole. I want to see a penguin.
You
Do
realize
what
you
now,
won't see a
Spurs?
24-hour day, guys. Do you realize you won't see that? You realize that,
You
right?
realize on
You realize
Earth,
that.
there is no South Pole.
That's because I've been to the South Pole. That by confirmation of that, there is no flat Earth.
Yeah, but
How
they
could
can
he
take
prove
you
it
to
to
anywhere.
you? How could he prove
Yeah,
to you that
anywhere.
he's going to South Pole?
Spurs. Now you need to demonstrate to me how they fucking made it so I was thinking I was going someplace else when I was at the South Pole. It's not like Spurs. It's not like I went there for Spurs. I didn't go there for 3 days. I went there for 13 months.
Mm.
Mm.
You lived there.
What the hell are you doing that you're going to the South Pole for?
Well, I'm contracting work.
No,
Actually, I'm going to be at a place
Compounding.
on this time. I'm going to be at a place called Black Island, which is south of McMurdo.
Okay,
You just angry
what
because
for
they
are you
tricked-
going there? I mean,
It's work. I'm retired now, so it's nothing. I retired from the Army, so what I do now is keep myself busy, make good money.
yeah, but I want to know what these people are paying you for. But
What is your
Oh,
actual
you talking about the job?
question? Yeah, that's the question.
Okay. I was confused by the question. What I'm going to be doing is I'm going to be what they call a site manager at Black Island. Black Island is a relay station for McMurdo, because McMurdo itself, the satellites that it needs to talk to are on the equator. And because of the angle from McMurdo to the equator, because of the angle from McMurdo to the equator, there's Mount Erebus is in the way. So they have very limited time that they have. They can see the satellites. So what they do is they shoot the shot to Black Island, which has a much clearer view of the sky over Mount Erebus, and that's how they talk to the satellites.
Oh, okay.
Oh wow, this thing is fucking close to the South Pole.
I know I think it's 77 degrees or some shit like that.
Yeah.
Anyways, back to Spurs' complaint. So Spurs, in 13 months that I was there, how did they convince me on my first tour in 92, 93? How did they convince me when I was there for 13 months I was not where I thought I was?
You were in the same spot.
Well, that's not what I asked you, Spurs. I said, how did they convince me? How, when I took off from Christchurch, New Zealand, and turned right and head south without turning left or right, where I can see Tasmania outside the right side of the aircraft and Australia, and proceed to fly south, where did I go?
It took you to an unknown destination, that's why.
I know where I was going, so it can't be unknown.
Yes, because the war...
So Spurs, how did that, when I was there for 13 months,
anywhere along
Spurs,
the wall.
how did they take me? Where did they take me? Where did they take me that was a frozen wasteland? Did they turn the airplane to the left and I didn't know about it and flew to the Arctic?
Are you that naive?
Spurs, I'm asking you a question.
You're very naive.
Spurs, I'm asking you a question. Because me being there is my experiment that I went out and did myself for 13 months. So
Yeah,
my test is valid.
The flights were wrong.
What do you mean all wrong?
The flights.
Tell me how I'm wrong. Tell me how they convinced me otherwise.
Oh,
tell me when I flew out of Christchurch, New Zealand, and we took a right with Australia and Tasmania on my right side of the aircraft, and we flew down south. Tell me where I was not. Tell me where I went instead of where I was not going.
You had to be prepared to learn. That's why.
They prepared to land. They prepared to land when they arrived at their destination.
Guys, I'll give this hangout 20 more minutes, and then I have to finish.
No problem. I'm just answering his questions.
No, you're not.
Well, I know, but... So, Spurs, how did they convince me for 13 months I was not where I thought I was?
Yeah, I'm going to post the link now.
I'm on my phone. I can't see it.
Well, you'd have to watch back.
I'm not watching any YouTube videos, Spurs, because I was there.
Us?
We mean here, us.
We're going to play the video here.
Yes, whoever has the carry, that's Black Island.
No, Spurs, I won't play this video right now. It's 15 minutes long, and...
That doesn't show anything. It's a guy with a globe in his hand.
Yeah.
Well, again, you don't want to learn. That's your problem, not mine.
Spurs, you don't want to learn. You don't want to listen to somebody.
Jump to that part.
Spurs, you don't want to listen because I was there and it shits on your parade. And not only that, I will be there again.
South Pole, that's your claim there is.
Spurs, I will be there again. And also when I'm there this time, because I didn't know anything about flat Earth when I was in my teens, my first time I went down there. This time I'm going down there and I'm bringing fucking photography equipment. I'm also bringing a 360 camera so I can also record the 24-hour sun that you guys say doesn't exist. That I've seen for 4 months.
Anyway, this proves the flat Earth, so I don't know what you're arguing about.
This flat Earth doesn't exist.
In 15 minutes, you could be a flat Earther, end of subject.
Spurs, you can get a job in Antarctica and not be a fucking flat Earther.
Cara, when you have time, debunk this, and then we can talk.
Go fuck
Spurs, you need to debunk me. Don't give me no YouTube video. You need to debunk me. Because you notice I don't provide you a YouTube video to show that I was there. Because I know I was there. I took pictures when I was there when I was 18 years old.
Watched. an hour flat earther all over. None of this rubbish.
Once again, audience, Spurs can't address me, so he's basically going to ad hom me up that I don't know what I was talking about. I was never there. He
You'll
can't
never
prove
get
that I was
anywhere.
never there. And
You'll
there we
never
go.
get anywhere with him on that one. I don't
I
think.
know. That shit's on his parade. Because
Because
according to Spurs, audience, according to Spurs, the only way you know something is if you do it yourself. So I went to Antarctica, and I know I've done it. So there's my proof. I've done my experiment. I've done it for 13 months. I'm going back down there again to do it for another 13 months experiment.
Pilot, ladies and gentlemen, yes, he flew the plane himself.
I didn't fly the plane. The plane flew there.
So arrogant.
You just said I went there myself.
Yes.
I flew myself.
Yes. I went there myself, and along with 300 other people on the aircraft.
All right, so you just flew. You're the pilot flying 300
I'm not the
people.
pilot.
So what are you talking about then? You're flying blind.
I'm not the pilot. You know, I sit in the back.
No,
You know, there's
he
windows.
didn't fly. He didn't fly the plane.
If you're a
Therefore, he
passenger, you
doesn't
don't
know
have-
where he took them. Apparently,
Spur,
there's
are you
some giant
wait,
iceland
stop,
nobody knows
stop,
about.
Well done, Cara. She's understanding.
Stop.
No, you're stupid.
Spur, are you claiming that if you're a passenger on a plane and you look outside the window, you can't determine where you are?
You can't.
You can't.
Yeah, you can actually quite well.
You can see
Do they
Tasmania from an
cycle your
airplane,
compasses
idiot.
Too?
No, you can't.
They
You're
change all the
incorrect, Ricky.
compasses.
Just hop into the next flight and fly to, I don't know, Algeria or something. You will see the coastlines matching up with your maps
doesn't
quite
even-
easily.
He doesn't even have to do that. He can go on a fucking bus and follow and sit in the bus. And that's the same thing. You can look outside and see where you're going.
You can also, like, pro tip, if you have a window seat, it might be, depending on what kind of fuselage it is, it might be a bit hard, but it's not impossible to get GPS signal on your phone. Just saying.
Yeah, that's a good idea. Actually, I'm gonna bring my Garmin when I go down there, anyways. But
You have to do a whole lot of
And
things.
if you want to fight about whether GPS is correct or not, I might be able to ask my dad about.
But the thing is, if I bring a GPS, Spurs will bitch about the GPS. If I take pictures, they'll bitch about the fucking pictures.
No, you need to record the whole journey from the window.
No, I don't.
24 hours, 7 days a week. Can't turn it off.
Yeah, for 13 months, I can report every fucking day for you, Spurs.
I said the journey, the flight. Record the whole flight from the window.
I'll tell you from a window.
My God.
Yes, the window.
So when you
Why?
fly, So when you fly, have you ever been to the U.S. or out of your country?
Where I am,
Spurs, once again. Spurs, once again. Have you flown out of England?
South Pole and show
Spurs, have you flown out of England?
Been all over the world.
Spurs, have you flown out of England?
He claims to have been all over the world for whatever reason.
So when you flew from England to the United States, did you record the flight the entire way looking out a window?
No.
So how'd you know when you went to the U.S.?
What do you mean, how do you know I went to the US?
I just asked you a question, Spurs. How'd you know you went to the U.S. if you did record looking out the plane the whole time?
There's American people there.
And there are people in Antarctica.
There are penguins in Antarctica.
Yeah, that's true. That's another thing too, Spurs. There are no fucking penguins in the Arctic.
Nope,
Like I
they
said,
all-
There are no leopard seals in the Arctic.
Making a
Trust
world.
And I
me.
didn't see a single polar bear.
Just record the whole flight.
Yeah,
That's what you need. To
No, Spurs. I'm not going to record the whole flight unless you give me a camera and you give me the SD cards. I will.
Well, there's nothing
And
to
the-
prove
and the
it.
batteries.
is
No,
Okay.
Spurs. That's my conditions. You want to do it? You pay for the equipment. And I'll suction, and I'll talk to the crew, and I'll suction cut the goddamn thing to the window. But you'll say that's invalid because I don't know what I'm seeing. I can never hear your excuses.
Or
I
I know that's
look at the
Antarctica.
camera.
I see nothing but fucking white.
Prove it.
How do you want me to prove it?
I just
You
told
could
you.
use the
record the whole-
stars, by the
And
way.
I just told you my conditions, Spurs. So when you, let me know.
24 days,
Hit me up on
that's
G
the
Plus and when you want my mailbox number. Make it quick because at the end of the month I'm packing my shit up.
Your claim.
24-hour day,
Right.
South Celestial Pole. If you could show you both of those, would you take it? Would you accept those?
Both poles.
South Celestial Pole and a
Yeah.
24-hour and whatever else, guys. I know I'm imposing things on guys, but
No, you're fine. Sean Hufford wants me to do one down there. I got a 360 camera. I just
Cool.
got to have. I have a 360 camera. As soon as I get down there, I'm gonna have some make one of the shops make me a dome so I keep that thing out in the weather the whole time, and I'm going to record that son. But you guys are going to bitch about something. Oh, it's got a fisheye. It's got a fisheye lens. It's a time lapse. Blah 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 blah.
Hey guys, hey, I'm in the South Pole. Check this out. That's what you're gonna do. Just like the sun tracking Antonio's been doing. You're gonna put the work in. Otherwise, you're making claims. Wild
Spurs are. There's over 2,000 people down there right now living that same claim.
We're talking to you. You're making the claim.
Spurs. Once again, how am I going to prove it to you, and so a way that you can't say I'm wrong?
Tell us, hey guys.
Spurs. Once again, when I go down there and I do these pictures and stuff, what's going to stop you from going? Yeah, that's got too much white in it, or that's got fog, or that's a time lapse. I don't like that. I don't like your airplane picture, your flight, because you didn't have it suctioned to the window when they took off. You put it on the window after they took off. You're going to have nothing but fucking excuses. You know what? While you're having excuses, I'm getting fucking... While you're having excuses, Spurs, I'm fucking making money.
That's all you can do, guys, is do your best and do your part.
Do my part? I already know where I've been.
Do what's required. Don't worry about what's going to be said.
Spurs, I will, because you're a liar.
Do it to the best of your ability.
Spurs, you are a liar and a deceiver.
Well, we'll see after you give us the results. That's all.
And you want to go into this whole results thing again? So once again, how do you want me to do this?
I've just told you.
And I fucking ignored you because you're fucking a liar.
That's why I don't tell you your method.
Yeah, because you want me to do... I told you, Spurs, you want me to do this thing on the window. You want me to record this thing? Then you buy me a fucking GoPro and all the SD cards that you want me to fucking record it to. And if I get permission, I will suction it cup to the window.
Nobody believes
And for the next fucking 5 hours, the flight down, hopefully record the whole way without the battery dying. Because if I got to change out the battery, you guys will bitch about the battery dying.
Wants to
Spurs,
see
why don't you just make a suggestion on something he might do to help prove it to you that he's gone to the south, that he's actually down there.
A live feed from South Pole.
There is a live feed.
Set some ridiculous expectation, just something that he could do while he's down there to show that he's actually down there.
Do I need to get like a piece of paper Spurs? Do I need to get like a piece of paper that says Spurs, you're a fucking idiot, and stick it right next to a penguin?
Listen, it's not about live experiments of what we can see and observe.
Spurs, there are live webcam down. Spurs, there's live webcams for there right now.
Why do you think Antonio?
Spurs, there are live webcams for Antarctica right now. How come you are not watching them?
You're about to do sun tracking with Antonio.
Spurs, you're deflecting again.
We're about to infer exactly where you are.
And I'm going to, what do you want? Spurs, once again, I'll tell you what. This is my standard Spurs. Here is my conditions. When I go down there, I'm going to get a nice big fucking white piece of paper. I'm going to write Spurs. I'm going to write on it Spurs. I'm going to write on it Spurs. Listen to me. Shut the fuck up. Spurs, I am going to prove it to you that I'm in Antarctica because I'm going to give me a big white piece of paper, and I'm going to write Spurs is a fucking retard on it, and I'm going to post it right in front of a penguin, and I'm going to take a picture of the penguin, and Spurs is a retard paper right next to it.
Yeah, we want
to. I proved I'm in Antarctica.
We're going to track your sun when you're there and tell you where you are. We'll give you your position, where you are on the edge.
You're going to tell me my position? It's not how you do that, Spurs. I'm going to tell you my position.
Actually, this is perfect because we will be able to tell you exactly where you are according to the tracking of the sun. This is great.
Spurs, are you going to have any flat earthers down there with me?
He thinks he can do that. That's
down there with you. You're going to.
I don't even know what Spurs even wants. I didn't even listen to him.
You're going to show us the sun and what time.
How do you want me to do this?
Don't worry, we've got Vinny. He'll sort it all
out. I don't care
about
Vinny. He's not in Antarctica with me.
He doesn't need to be.
Yeah, he does. Remember that whole thing you talked about earlier? You need to have that third person. Where's my other and third person?
Yeah, exactly. You're going to be in one position.
No, Spurs. They need to be there with me. They need to be there. They need to be there to confirm what I'm seeing.
This will be more than A, B, and
C. Spurs. I need somebody there with me to confirm with me that what I'm seeing.
We're gonna have the whole alphabet, guys. Don't you worry about A, B, and C.
Spurs. Spurs? What is the problem with you about being a fucking liar?
We're gonna cover the whole map. And
Spurs,
I'm so confused about what's happening right now.
I am too.
Spurs being Spurs. That's what's happening. It's happening.
Spurs, there's a webcam. Spurs, there's 2 webcams down there right now live. One is at South Pole Station at Edmondson Scott, and the other one is at McMurdo. You can do your sun shit all fucking day right now, and I'm not even there.
Yeah, I actually posted to the Amundsen
now,
one.
guys, I hear nervousness in your voice. We want to track
Nervousness.
No, it's annoying.
I don't think it's
It's
frustration.
annoyance.
Because you don't understand anything. It's frustration, nothing more.
Well, they were meant to be frustrated. Just worry about your solar noon, and that's what we're
My
going to
solar noon.
I think he wants
Spurs,
you to
how
take
would,
a picture.
Spurs, how would I find out solar noon?
Which is
Told
okay.
you. You've got Vinny and the boys, and then
I don't care about Vinny and the boys. Is Vinny and the boys down there with me in Antarctica? No, they're fucking not.
I've got experience in tracking the sun now, so
How you gonna track the Antarctic sun in England?
you're going to tell us, Geist.
No, but
shit.
wait a minute. You don't believe me.
Well, are you a liar?
You already told me I'm a liar.
Are you a liar?
You already told me I'm a liar, and no, I'm not.
Right, so if you're not a liar, you're going to do this sun tracking, and you're going to show us.
Wait, why is that necessary?
Yeah, why is that necessary in the first thing? There's your whole argument. First off, Spurs. First off, your whole argument is if I'm in Antarctica or not.
Yeah,
Can he
so we'll be
just
able
bring
to
a
tell you that.
GPS?
No, we're going to track the sun.
But why can't he just bring a GPS?
No devices. We're going to use what God created.
Okay, hold on. If I can't use no devices, then I cannot talk to you by the internet.
Well, you could
I
use a
cannot use
sextant.
cameras.
We're not using the camera.
you could track the sun.
Guys.
No, Spurs. I can only use what God gave me. That means that I cannot use a camera. I cannot use the internet. I cannot use an SD card because none of that what God gave me. I can only use my eyes according to you.
The internet is
Well,
for
I mean,
communication. We're not measuring.
Well,
No,
guys,
Spurs.
Guys, you could use like smoke signals.
I can bring my fucking sextant down there.
Because then you're using fire and
That too. That would be awesome.
aerodynamics.
But Spurs, you don't even know how one works, so I'm not worried about that.
Wait, Spurs, why to confirm his location, why can he not use a GPS? Wouldn't that be the most reliable way to know where he is?
No.
No, because
Why
satellites
not?
doesn't exist.
Yeah.
Satellites don't exist. Yeah.
The sun is the enemy. The sun and the moon are the best satellites to tell you where.
But why can't he
the
use the
sun is the
GPS?
satellite.
Tell me why he cannot use the GPS.
They've been. Well, what I mean is people use.
If I get my exact position, then that would fuck up their whole thing. Because what they'll say with the sun is, well, he's not really in Antarctica. That he's really over in Greenland, and he's just trying to lie to us.
Well, what if he showed you a 24-hour sun? What if he showed you a 24-hour sun?
You're going to do a sun tracking in South Pole.
What if he showed you a 24-hour sun?
Yeah, whatever. Do what all you can in the South Pole.
I'm going to.
If he did, what do you think of that? Is that good? Is that evidence of where he is? So this is your problem. You never accept that there's something that will convince you. You never do. So what will convince you? What evidence would a 24-hour day convince you?
24-hour day, yeah?
In the middle of winter for the northern hemisphere.
Yeah. Well,
24-hour day in Antarctica.
Spurs, do
would convince
you realize in Antarctica, when it's winter, it's summer somewhere else, right? You know, the seasons are reversed. When I go down there in May, it's the beginning of fall. And I'm eventually not going to have 24-hour sun. I'm going to have 24-hour night for 4 months.
Summer, autumn, yes? Okay. So you've got a task now to do. Yeah?
Spurs, you don't tell me my fucking task.
Oh my God.
You're fucking pretty arrogant for a guy who fucking hasn't been anywhere.
Spurs.
So you've got a task to do. You've got to record your journey to prove that you're going all that way.
Yeah, once again, Spurs, and how when the SD card fucking dies out or the battery dies out on the GoPro stuck to the window, we're just gonna stop you guys from bitching about me stopping the camera to change out the battery and the SD card because the GoPro doesn't last 4 to 5 hours. You'll say, "Oh, there's a break in it. That invalidates it." That's what you'll fucking say.
Well, if you're worried about doing, the answer before doing the test, that's your problem.
This has to be a
No,
live
I'm
stream. No
yeah, because I
cuts,
know
no-
what you guys are gonna do. You guys already do it on other videos.
Why can you? I still don't know why you can't use a GPS.
Because in Spurs world, satellites aren't a thing.
Guys, I need to
It's
end it.
radio transmitting.
Okay.
It's
All right,
getting too
Gio.
late for me.
Yeah.
We've been talking now 4.5 hours or so. So for
Yeah, we're good.
everybody watching, thank you very much. And
Thanks, everybody.
bye.
Bye.
Hanging up.